Well, according to my clock, we have hit the top of the hour. Jelmer, are you good with me getting started?
Let's go, Julie.
All right. Wonderful. Well, I just want to welcome everyone to the final session of the WML Weather and Society Conference. Really briefly, I'm Julie Demuth, and I'm a senior scientist here at the National Center for Atmospheric Research in windy but very sunny Boulder, Colorado. And I've had the really good fortune to be able to co-convene the session with Jelmer. And so with that, I'm going to hand it over to Jelmer, who will give opening remarks, and then we'll segue right to our keynote. So Jelmer, take it away.
Thanks so much, Julie. Yeah, hello, everyone. Also welcome from me for this session on the roles of AI in forecast and warning services in user responses. My name is Jelmer Jeuring. I am a researcher with the Norwegian Meteorological Institute, and I will chair the first part of this session that I'll be co-chairing with Julie. So yeah, just a brief introduction of the theme. Artificial intelligence, it's everywhere, right? So surely in some form in the daily lives of most of us attending this session, but also, and more importantly, it's that in our professional lives, AI technology is not only transforming how forecasts are generated, but also how forecasts are understood, communicated, and acted upon. So in this session, we will explore that transformation and highlight how artificial intelligence and technological developments require integrative, technical, and social science perspectives, both about what topics we research, but also how we actually do social science research and apply social science methods in our field of work. So in this session, we will have a set of presentations from across the world that cover a set of very timely topics. So it ranges from operational implementation of data-driven early warning systems to AI-based technology that can strengthen community resilience to extreme events, from addressing ethical questions around bias, transparency, and accountability in AI forecasting to the dynamics of trust, perceptions among both providers and users of AI-generated forecasts. But also from co-production and transdisciplinary frameworks to integration of operational AI with social science research, as well as the implications of personalized multi-hazard risk guidance using AI technology. So after the presentations that we will go through in different parts of the session, we will have a forward-looking panel discussion where we invite the audience and our presenters as well to reflect on the possible implications, also the next steps for how social science insights can help the weather community to move beyond technical promise to practical, equitable, and ethically grounded AI-based applications for all. So we encourage active participation from the audience. Isha, if you move to the next slide, we also have a few housekeeping notes that we would like you to pay attention to. So on these slides, you see several of them, and the most important are that you mute your microphone unless you were invited to speak. And note also that this session is being recorded, so please switch off your camera if you prefer to. And finally, for the interaction with the audience and with the presenters, please submit your questions in the chat during the talks. After each presentation, there is time for a Q&A, during which the moderators will read out the questions. And that will be Julie and me. So with that said, I think it's time to start off and welcome our first keynote speaker, Christopher Wirtz. Chris, you can turn on your camera. And you're sharing your screen already, great. So let me first introduce Chris before you go ahead. So Christopher is an assistant professor and extension specialist at University of Illinois Urbana-Champaign in the US. He is studying risk and science communication, and his current research focuses on communication among different decision makers and audiences in the face of environmental risks and technologies. Much of this work has focused on weather hazards and the development of use-inspired AI. So today he will be sharing insights from this work in his talk that discusses how social sciences can be leveraged to understand the trustworthiness of AI and machine learning methods for forecast and warning services. So Chris, if you're ready, please go ahead. The floor is yours.
All right. Thank you so much for the introduction, and thanks to both of you for having me and inviting me to be the kind of keynote kickoff speak, which is a little stressful, but we'll get through it. In addition to thank you for hosting me, I also want to say I'm going to channel my former supervisor, Julie, and acknowledge folks up front. And a few people that really were central to making the research happen underlying these things, but also kind of the ideas that underline them, and think kind of like consistent thought partners on these things. And so the first group would be a core group of people that we work together on many different projects over this grant. Be Julie, as well as Mariana Keynes at the National Center for Atmospheric Research, as well as Ann Bostrom at the University of Washington. It's kind of a core brain trust of folks who have been thinking a lot about social science in the space of weather and AI development for quite a while. So shout out to those wonderful collaborators, as well as a few people who you will see later on today, Miranda White and Carly Sutters, students who I've had the honor of working with in digging more into these spaces from different perspectives. So we kind of thinking in our social science lens, and then broadening that out to thinking, how do we actually put some of these ideas into practice? So some folks that are, again, really awesome and important thought leaders in my work and guiding how I think about things. And there'll be many more co-authors that I started listing them all out, and it got to be a little bit like the credits at the end of a movie of people who also make this work happen. But I include the citations of the work that we talk about below if you're interested, but a shout out to all the great collaborators. And then also, you can't show the people who participate in your research and social science research, but giving a shout out to a lot of the folks that are essential for making this research happen, right? Who take the time to talk with us, who share their ideas and inputs and insights and kind of the things that they grapple with. And so we can start to learn those and work at them into our research as well. So the National Weather Service forecasters and folks from the public. And then also obviously sponsors for the work, National Science Foundation, RAI2ES funding, as well as NOAA for some of these projects. And with that out of the way, I want to give a little bit of kind of background here on who I am and why I'm talking to you. My background, I come from the University of Wisconsin-Madison is my training, and I studied a lot of different pandemics as well as genetic technologies and a few natural hazards, where really I am an expert in risk and science communication. That's what I've studied over time. And then I had the honor of going to NCAR and working with Julie and a bunch of different weather-related topics and AI development, where really focusing on interdisciplinary science and convergent science, so coming together around a common problem to deeply integrate across expertises to make meaningful progress in both science and societal applications. And now I'm at the University of Illinois, like I mentioned in the intro, thinking about kind of how we get in these broader environmental and weather-related spaces. And so that's who I am and where I'm coming from. What I want to cover today is thinking about giving us a foundation for thinking about trustworthy AI. What does that mean? We talk a lot about trust, but what does this look like in practice with a social science informed way? And then I want to think about the connections between the human and developmental aspects of AI systems, right? So how are we pulling together the social systems as well as our AI systems so they complement each other well, and what does that look like? As well as then thinking about how changes and kind of advances that we make in these AI systems may both like directly and inadvertently impact some of these human systems. Those are the broad sort of topics I'm going to cover today. And then this whole sort of idea builds towards a goal of providing a foundation for our discussions for the rest of the day that helps us kind of deeply integrate the human development aspects of AI and forecast warning systems, right? So kind of pulling together that intersection of social and development. So trustworthy AI has gained a lot of traction. I'm not sure if it's in everyone's circle, but it's definitely something we see a lot in policy, right? So policies from around the world are mentioning the phrase trustworthy AI specifically and working towards try to advance that. And not just in policy circles, but we're also seeing this from different funding agencies making kind of that claim that we should be working towards trustworthy AI, as well as a lot of research has started to build around this concept and phrase, as well as the private sector thinking about getting in this space as well and offering some, trustworthy AI tools as things that you could have. But the problem here is what's meant by trustworthy AI is often unclear and inconsistent. And I think to move forward effectively, we need to be pretty clear about what that means and what it doesn't mean. And so really what we see a lot of the times, this is kind of some broad maybe overgeneralizations of trustworthiness in this AI space, is it's generally what we call atheoretical, right? It's not connected to deeper understanding or some sort of measurement or kind of rigorous work, but instead it's really variable, kind of what people are thinking that it means in their own minds, and encompasses a lot of different things. So like some subset of dimensions, it has to follow these principles or it's done in this way. They may not be connected to what we know about the actual concept of trust or trustworthiness. And it tends to emphasize model performance, right? Kind of like the models do well, but not be very precise in what that means. And generally what you see is it's often something related to appropriate use, right? You're seeing trustworthy AI is AI that's used the way the developer intended it to, which maybe is one component, but it's not comprehensive, as we'll talk about. And so with that, there's really this strong need to lay that clear, consistent foundation on what we mean and to look to social science for doing that. Because if we don't really agree on what trustworthy AI is, then this sort of fractured and short-sighted efforts are often going to fail, and they could potentially backfire, right? If you're telling people who they should trust or what they should trust, and you're not being consistent or doesn't align with how they understand that concept or with their values, you may actually go further backwards, right? Or you tell someone to trust something and then it goes against what they think, and then it ends up not working out for them. They may not trust any sorts of new technologies for quite a while in the future. So it can be not only not work, but it could go backwards. And there's also a lot of different things you can learn from social science, which is what I'm going to cover. A paper that we've just recently produced is thinking about what we can learn from social science about trustworthiness to guide our efforts in this AI space. And so when we think about this, there's a big foundation out there from literature around on trust in different spaces. And the first kind of common thing to think about is that when we look at a bunch of literature, interpersonal trust is one that stands out, right? We have a lot of research from last several decades about trust in other people or in groups of people, right? So things like, do you trust your organization, that you work in to sort of like push forward your values or to take care of you? Or do you trust, a partner to follow through on certain promises and things like that? And this sort of work is probably our most foundational trust work in the social sciences that has led to a few different relevant branches for the AI world, where we see risk and trust is another flavor here, where it's trusting people and institutions involved in risk management. So what I mean by that is it's essentially, would you trust policymakers, to manage some sort of crisis, or to trust scientists to develop tools effectively, or to kind of have your values in mind as you go. And so it's really kind of trust in those management systems. And at the same time, we have a lot of literature that's come out around trust and automation. Do you trust automated technologies? Comes out roughly around the 80s, thinking about things like the automated milking machines or some sort of autopilot systems that you may have, and seeing if people are trusting those and making effective decisions. And then we think about how this is then, you see this in the literature, somewhat translating towards what trustworthy AI is AI worthy of users' trust? And we see sometimes folks are pulling on the interpersonal trust, sometimes people are pulling on the AI and automation sort of literature, not so much from risk and trust. But this is generally what we're looking at as far as where the concepts are coming from. But when you look across all these different literatures, there's some really key points that are helpful for us to consider when we're thinking about trustworthy AI. And the first one is that this concept of trustworthiness is really relational and perceptual. And so what I mean by that is it's going to be the result of a subjective evaluation, right? So someone, right, so this is the relational part, you have a truster, is going to decide, to what degree are they putting their faith in or relying on some sort of system or other person, right? So that's the relational. You have to have a trustor and a trustee for this concept to even exist. And then trustworthiness is an evaluation of, to what degree are you doing that? Are you trusting someone? And essentially, it's going to be that truster perceiving the trustworthiness of that trustee, which is counter to a lot of things that we see in other sorts of discussions of trustworthiness, where we've tried to define it as this inherent characteristic, right? This objective characteristic of an AI model. We can give the AI model a score out of 100 on trustworthiness, or we can say that it is, definitely a trusted model or trustworthy model or not. And it's generally not how it's going to work, right? We can't just look at the bottom of the model and see, or like on the bottom of someone's shoe, that they're a 99 of 100 trust score, because it's going to matter who's evaluating that. What factors are important for them, right? We can't just prescribe that universally, because it's also going to matter, again, the next point here is on context, right? So AI is going to be deeply embedded in interrelated contexts. And it's going to affect how these people are making their evaluations and perceptions of trustworthiness. And so we pull and look around here. A lot of what we focus on is that development context, right? So what techniques were used? What are the data? How does the model, perform and verify? Is it explainable? Is it interpretable? All the things we think about a lot in the science and technical development stuff. And those are definitely important concepts for us to think about for trust, especially with more of the technical audiences who may be perceiving this tool. But then we also need to make sure we're really considering that use context, right? So what is the purpose or the goal of this model? What is it meant to be doing? So is it going to be making a decision for someone, which may be very different than just providing information that guides a human decision? And so making sure we have the ideas down around what the implications are of that decision and kind of what sort of responsibility or autonomy these tools have and how they play into the human system is going to be really key, because it's especially really important when we start to get things into operational context, right? Making sure people actually understand and know how it's going to fit into their world, and making sure we as developers also are aware of and working towards those contexts. And then above all those things is thinking about the policy context, right? Knowing how is it going to be governed, essentially. What are the relevant standards or benchmarks that are going to be used to make sure this performs well? How does this kind of manage the different social systems? What does enforcement look like for these different policies, and how will that be updated over time? All of those concepts are really going to affect how we think about the assessment of trustworthiness for our different users or communities that could be affected by the tools that we're developing. And so kind of pulling this together, thinking of an example, like if you were looking for, you just moved to a new area and you need a babysitter or a pet sitter or someone to watch your plants when you're going out of town, and you go to a website because you don't know anyone, and there's scores of trustworthiness for these different potential caretakers, right? If you see someone who's got like a 95 out of 100 on their trustworthiness score, you probably have questions about how that was done, right? But do they know about, my child's needs? Are they kind of important for these sort of cultural contexts? Are they ready to care for this type of plant? Because you're essentially kind of demonstrating there that you're going to need to know the context and sort of like how that's done, because it's a decision you have to make and it's a perception you make. And you can also think about this too when you imagine a colleague. You might trust them to have wonderful, great ideas in the meeting, but not trust them to do, their write-up or homework after that meeting before the next one, right? So it's even within the same person, it's hard to identify what their overall trustworthiness is because it matters for what, in what context. And so we pull these together in this paper to think about, as we talk about, trustworthy AI, let's really focus on the social science foundations that we have from a lot of literature that's out there, both through conceptual work and through data-driven work, is that we can remember these 2 points, right? It's going to be perceptual. It's in the eye of the beholder. We can't promise it that it's going to be trusted by everyone. And instead, we have to work towards understanding our trusters and their relationship with the AI as a trustee, and that we're also navigating a lot of context. And so when we're thinking about trust, it has to be considered trustworthy in the eye of the beholder here across the use, development, and policy contexts. And this may not be the same across multiple people. And so I want to lay that foundation here first for our understanding of the sort of AI systems. And I want to talk a few points here about how we connect the human and development aspects of AI. And so when we think about this sort of connection here, is going to be an oversimplified kind of traditional view of model development. We have a model, we make it, it's great, and we send it out to be operationalized. And maybe we throw a little social science sauce around it, and we get some work done to make sure it has a strong evaluation, people love it. Sure, not many people think that way, but I want to kind of complicate this a little bit more and think about what does an integrated approach look like to this? Like, instead of having a tool and throwing it over the fence, can we think about how we focus on operations? What do people really need to make decisions? And how can model development and social science work together across those perspectives to be very deeply integrated? And this is not enough arrows, right? I should have, in, back, for, in between all these different boxes and, sort of recursiveness, but I'm just going to simplify it. These all need to be integrated and working together. And so the first example I want to talk about is how we can think about social science improving model development. And so this is goes to a common approach we use in machine learning called supervised machine learning models, where they're using a lot of human labeled data as a training set of what the ground truth looks like, and then the AI is trying to learn those patterns. And typically, the approach looks like we have this model is trained by hand. We maybe have a vague sort of understanding of what the concept is. We publish that in a paper in a paragraph or two, and one person is making a lot of decisions, and we don't know how consistent they were. And so it makes it pretty hard to evaluate those black box tools, like the data underneath even the AI tools. It's hard for a practitioner or researcher to really know what goes on. And so we're talking about doing is we developed a method actually with a lot of folks on this call, is looking at bringing in an approach from social science called quantitative content analysis to try to eliminate some of those shortcomings in how we typically do this, right? So social science has an approach where you can document out in what's called a code book, or essentially like a decision guide of how all these decisions you're made are going into some sort of documentation, right? So what does it mean for a road to be snowy or wet or dry in an image? And how might we classify that? And what are examples of what it looks like? And you can publish that so people can investigate how your decisions were made. And we also have tools for assessing the reliability to see if people are making decisions consistently using different statistical approaches, which makes it more valuable and transparent. So we can see how the data were generated. And then we also have a good understanding then of how we are moving our tools along. So this example gives us an idea of kind of sort of where we need to be going and bringing together the social science into that development context to have more robust approaches that are going to address human needs. And so what it's also, I think, is important for us thinking about, we have a lot of shoulds, things that we should be doing, but not clear documentation on how. And so in this paper, we outline exactly how you would do these things instead of just saying you should be doing this more robustly or you should be working with users. We're trying to provide some of that more concrete guidance. And then the next thing is thinking about, how can we understand, like use social science to understand these operational contexts. And so the second study I want to talk about here is looking at National Weather Service forecasters in the US and understanding just a baseline of how these people are assessing the new tools and making trust sort of assessments. And what we found is talking to forecasters over 2 years through a series of interviews, and with ChatGPT coming out right in the middle, is you see a big range and openness to these tools that's not even going to be, and same with familiarity, with people knowing a lot to not very much, that doesn't even follow clean like age breakdowns like it's easy to assume, but really the guiding factor being that people are open to tools if it really builds towards the mission that they care about, right? So providing the best possible forecasts and services was the big driver for folks, but we did learn that there was a lot of need to kind of address some curiosities and questions folks had, and that in the end of the day, pretty big range on the openness, but people were interested in the tool if it did a better job. And so an example where like learning where your user base is at helped us kind of guide into synthesizing these findings for folks to develop to them, right? So understanding where their questions are, where their concerns are, helps us communicate more effectively when we start to bring these tools out into the public. And so bringing the last section, I'm not going to talk about because this is really a strong section where you're going to hear more on from later today. So Carly and Miranda will talk about things of like the model development perspective and how we use social science and getting a different operational context too. So stay tuned for that. But just giving the idea that we're bringing these systems together, right? We're thinking about deep integration. We're not just moving from a done model and maybe a little social science on the end and going into operations, but we're thinking about how we're meeting operational needs by deeply integrating across all of those different domains. It's, I think, where we need to be going. And so the last thing I want to close up here is thinking about how then when we develop these sort of integrated systems, that we have to understand the impacts they may have on one another when we bring these new tools. And so an example here is thinking about when we have a new advancement, right, a new tool or a new way to communicate or a new sort of form of forecast or warning system, they may have these unintended consequences. So what we need to do is before we're starting to operationalize these things, both in our forecast systems and warning systems, that we need to do it very carefully, right? And do a lot of robust social science research because we don't want to make sure we want to make sure we're not breaking the system, right? We don't want to, we have a problem with algae in our lake and we introduce this new mussel that's going to clean up, a little like mollusk that's going to clean up the water quality, but then it actually ends up over cleaning things and we disturb our whole food chain in the water, right? And we ruin our lake, right? So we want to make sure we're introducing a new system without breaking an old one as we do this. And an example of how we've tried to investigate this was looking at how audiences are making sense or responding to potential updates and warning systems. And so work you did with Julie is thinking about residents in the southeast of the US who are prone to a lot of these nocturnal and very big tornadoes. How do they respond to potentially probabilistic tornado forecast information and warnings? And so what we found is we gave folks a bunch of different scenarios and sort of probabilistic information to see how they would assess their risk and how they trusted different types of information. And you find that there are trade-offs, right? Depending on what sorts of information you're showing. So giving a lot more of these sort of probabilities maybe helped people make more fine-tuned decisions, but it also kind of maybe lulled people into a sense of false security where, hey, I'm not in the 90 percentile, I'm only in 70, and it looks like it's past me, right? Well, that's actually not what the warning is communicating. So maybe we have some negative implications of showing this information. Versus are we scaring folks, or people want to know how did they get to these probabilities? Or how do we communicate what a successful event is? If people are in that 0 to 10 and there's still a tornado there, they're still going to perceive that as a success in the forecast. And then much less thinking, how do we actually verify these probabilities in a meaningful way so folks can make good decisions? And so truly trying to make sure that before we do anything major, we know what some of the potential implications are, and we can work to address them before we have this go live in a high context situation that could damage trust in our forecast communication and warning systems. And so pulling these things together, I want to make sure we kind of think about this concept of trustworthy AI and knowing that it's going to require a lot of integration understanding, not just from social science or from computer science or from atmospheric science or from operations, but a deep blending of all of those things. And we're making a lot of progress. We've done, some sort of events and papers around and workshops to try to figure out some of these details, but there's a lot of stuff we need to do, and it's got to be, in my perspective, done with all of our expertise and thinking about what that means for policy and all those points. So with that, those are my key points. I hopefully have left enough time for questions here. I'm happy to dig into any more of these specific studies. These are just kind of the tip of the iceberg and kind of my specific thoughts, but I will pause for questions then. I can stop sharing too.
Thank you. Thank you so much, Chris. That was great. Very interesting to see this overview, and I can imagine there are some questions. I want to invite people to write their questions in the chat if you have them. So now is the time for sharing your ideas, and I think Chris is happy to answer any. I was wondering on your last slide, you were mentioning changes that are needed in policy to actually advance like our knowledge around how to move on with AI implementation and social science contributions. What can you mention some specific changes that you feel are needed?
Yeah, so I think the broad goal there is thinking that we can't do this in isolation of policy, right? So we have to have this system where we're working between like our development capabilities, our understanding of social systems, but also then working within the political systems that exist, right? Like these are not going to be things that just happen in science and get handed into operations. We have to consider some of those things. And I'm not sure exactly how this works around the world, but like a lot of the times in the US, we have pretty strict guidelines on what can be considered operational, right? What people can actually use. Right. And so that's something that you're going to have a lot of evidence to be able to show that this is the right tool. And maybe that's not going to move at the same timeline or have the same standards as the kind of cutting edge science facts, right? Or maybe we don't value social science and that knowledge as much as maybe we could. And so thinking about when we do work towards policy, that we are thinking about our developmental capabilities, and as well as our social science understanding of the systems of what can go wrong, as well as then meeting our operational guidelines and constraints. So it's kind of, I mean, it is a broader high level point that like, these are not systems that can work, the science will figure it out and then we just put it into policy, right? They have to be more integrated than that, because you can't develop the science in isolation of the policy system, because a lot of times that's where you're going to hit gridlock, is the thing that you developed is not something that's actually maybe mandated to be done or can be used or will work within your system. And so kind of making sure that if you know the goal for your product development is it to be put into some sort of operational space, that you're thinking about the policy it's going to have to navigate. You're thinking about the human system that's in the design of your tool, not just in how you try to market it when it's done, if that makes sense. So thinking more about like the considerations broadly of, kind of like a lowercase policy, not, 14 policies need to happen tomorrow. If that makes sense. Does that answer your question?
Yeah, I think so. And would you agree that that's not completely an exclusive challenge just for the context of AI? It's more also applicable for the general integrative needs between social sciences and atmospheric sciences already before the AI era, right? Yeah.
And that's something too, where we talk a lot about is like, what is new or unique to AI, right? Some things are and a lot of things aren't. There's a lot of issues that we've had before in forecasting in other domains that we have not really resolved probably, and that are just coming up again in new light, right? So I think a good example that Julie and I talked about too is ethics. Like we're not really concerned about ethics. And like we've been concerned about research ethics for a long time, right? You should be doing ethical research always, right? Like you should also be doing ethical AI research, but there's ethics and bias that come into play in a lot of different factors. And I think it tends to surprise people to realize that every time a social scientist does a study, we submit it for ethical review, right? We have to do those things no matter what, even if it includes AI or not. And so it's spot on that some of these things are not totally new. And same thing, the rule with humans and tools, like we've had tensions in those systems with models and forecasting since the 70s. People have been publishing about some of these things.
Yeah. There are some questions in the chat for you. So I will read them out loud. You're probably able to read them as well. But Helen Roberts from Met Office UK is saying that it's a fascinating topic. And she's writing that there's a concept of trust in intention versus trust in action particularly relevant for trust in people and organizations. What are your thoughts on that intention aspect for a machine learning / AI model? And can or does it have an intention, or should we disregard that and just focus on ability?
Yeah, so this one's a great question and sort of challenging because we then have to nuance who the trustees are, right? Are you generally trusting a specific model? Are you trusting the system that's like the people who are putting into place, right? Say that's your, forecast office, or that's your sort of aid agency that's making this tool, or the people who developed it, right? So each of those are going to have slightly different intentions, right? So you could trust that this team meant very well to make a tool that did work really well and they did their absolute best. You may trust like an agency to make the decision of which tool to use and to be putting into practice and that they vetted it correctly. And you essentially then have to then trust the model to do well. And the intention there is going to be very different, right? The intention of the groups, that's easier to assess. Whether the model has intent is something that's pretty contentious in a lot of literature. There's a lot of folks who actually say we shouldn't say trust at all about AI models because it's ascribing human qualities to them. A lot of philosophers will freak out if we have these discussions, for like in some ways good reasons. And so when we think about intent, is making sure we're spreading it out. Is it, and who's responsible? We think a lot about responsibility in AI systems. Is it the person who made it? Is it the person who said, yes, this is the tool we're using, or is it the tool itself? Right. And I would caution against pushing responsibility just to a tool, but the same that you would push towards, any other system. Like it's got to be more robustly governed than that. But I think identifying the intention of the teams is good because one trap we have in a lot of these systems is people love their model that they worked on forever. Whether they're able to admit that they're just in love with it, or it's actually because it's the best is also tricky. So thinking of the intent of those sort of developers is a really good one to parse out. So I think it has a lot of play in how we talk about each of those different actors. But I think how it comes into practice for AI is going to be different based on which of those trustees you're thinking about.
Thanks. So there's another question from Eva Latsuo. Social science work often takes a long time to accomplish, and at the same time, AI applications are happening at warp speed, right? So how can we align those different timescales to get operationalization happen with all the required evidence from all three systems? And I want to note, can you give a quick answer now, because we plan to go into a bit more deeply later in the session.
Yeah, because this question keeps me up at night, and it's actually when y'all asked me what question I wanted to add to the debate. That's the one I added, right? Because I think that's essential for us to figure out, right? We are at conflicting timescales, and so my short answer is: how do we sort of kind of institutionalize or kind of put into what we call social science theory some of the more generalizable points, so that we don't keep reinventing the wheel in each of these domains, and try to identify what are those key core context factors that have to be done for each model or in each context. So we can start to instead of starting at square one, we're starting a few paces down just to start to narrow that gap. It's kind of more robust theoretical knowledge on the social science side, on these more evergreen concepts. So things that are going to apply to everything, not just one specific model. Yeah. But yeah, we'll talk about that one again.
We'll talk about it later. So Eva, if you are planning to join the whole session, don't worry, it's going to be addressed a little bit more as well. So Philip has another question, and it's a more conceptual, and he's asking about how usefulness and trust as a concept relate to each other, because something might be useful even if we don't trust it.
Yeah.
And vice versa.
That is a great question, and I'll add a few more messy words to kind of add to that, where it's like, then how do you compare trust and confidence, right? Do you trust something or are you confident in it? That's something Julie's waded into in some of her work, as well as then reliance. What's the difference between relying on something and trusting something? And I think for usefulness is a great example we're talking about, is those are pretty clearly different things. And I think the clearest example we have is when we look at aspects around defense, right? You could have a very accurate AI model that's used for deciding who to kill in a context or not, or facial recognition or something like that. And I don't think there's any level of performance that would make a lot of people around the world trust that tool, right? And so it's the idea of you're putting your values and how you're perceiving that against the performance, right? Because we don't think that those are necessarily the same thing. So usefulness, and the same thing too, is imagine a decision maker is hey, this is going to be something that replaces your decision-making power, right? And you're like, that's something that people are also probably going to resist, because of how it may be useful, but maybe not actually in line with their values. And I think too, then we get to reliance and confidence. Those are even messier, probably closer concepts. And I know Carly's has some data and results on that. I don't know if she'll talk about it later, but those get even messier, right? When we think about those. But great point. They're not the same.
I think we have time for one more question from Sally Potter. And she's asking what you think are the similarities and differences between trust in AI and trust in other models, channels, and or other sources. So for example, should we be more or less concerned about trusting AI versus trusting a physical model that is a black box to most people already also anyways?
Yeah, I think that is a really good question. We've seen discussed in a few different ways in working in this space. And mostly they're going to have different considerations. And so I actually had a really good conversation in an interview with the forecaster, who's someone who was working in operational context, but had done graduate work in AI, and said, like, I want to know because the questions I would ask would be pretty different, right? So if it's an AI model, I'm going to dig into the data and the training a lot more because I know our AI models are much more sensitive to the data that they have. And so the example there is like, working in Southern California, if you have a tornado, being predicted in one of your physical models, versus there's nothing there in the AI model. It's like, well, there's probably not a lot of training examples of tornadoes, of extreme events that are very unlikely in your AI data set. So is it going to do well? They're getting those big extremes versus a physics-based model could see the variables that are there and kind of come up with a plausible solution, even though it's never seen it, right? And so thinking is just trusting them in what context and when, right? And so that's kind of mapping out your grid. It's probably going to look different. And so we have to be able to communicate what those different indicators are that are going to be important for people to look at.
Yeah, great. I see there's more questions coming up, and feel free to keep writing them in the chat. Chris, I hope you're able to have a look at the chat and try to answer them there. We're moving on now. Thanks a lot for your keynote. It was really interesting and a great introduction to the other presentations. I will hand it over to Julie now to introduce the next block of presenters.
Yes, Julie, wonderful. Thank you. I will grab the mic. Thanks, Jelmer. And I think, Chris, since you started off, since we did our initial welcome, I think our audience size has pretty much doubled. So welcome to everyone we didn't get a chance to say welcome to earlier. And again, thank you, Chris, for this fantastic, thought-provoking, and deeply rooted in the social and behavioral science literature to kind of kick us off. Our next session is the theme on toward operational applicability. We have 4 speakers, and I have warned them all that we'll all be sticklers with time, just because we have so much great content and really fantastic questions that are coming in. So I'm going to kick it off, and I'm going to do my best to pronounce everyone's names properly. Stefan, I hope, Steger, who is at Geosphere in Austria, the National Geological, Geophysical, Climatological, and Meteorological Service of Austria. Stefan, you are sharing your screen, and as soon as you kind of get going, I will set my timer for you.
Okay, is it working? Can you see the screen?
We can, wonderfully, and we can hear you too. Take it away.
Okay, thank you. So thank you for having me for this presentation. So what I will present today is a data-driven model for impact-based early warning of mass movements, so different kinds of landslides in the Alpine region. And what I present today is actually based on a preprint currently in the second round review in natural hazards and earth system sites. So from the background, everyone probably knows in this session that the meteorological services, including also Geosphere Austria, for instance, so in Austria, aim to transition from traditional weather-oriented warning, so what the weather will be, to procedures that estimate more or less the expected impact, so towards impact-based warning, so what the weather will do. And actually, this transition requires the consideration of many aspects, so not only looking at meteorological conditions, but also at socioeconomic factors, geo-environmental factors, and so on. So we need to have a risk perspective. When we think on the topic of landslides in general, we know that each year in the European Alps, for instance, rainfall-induced landslides cause considerable damage and fatalities. However, when we look at, especially at large area existing landslide early warning systems, we also see that they usually rely on non-spatially explicit empirical rainfall thresholds, as you can see one down here, that actually give you just the information on critical precipitation for the initiation of a landslide process. However, we have nowadays many possibilities and data, so data-driven models that integrate this weather perspective with other geo-environmental factors, socioeconomic factors are still rare. So the aim of this study was to create a data-driven, so machine learning-based approach to dynamically assess the impact potential of mass movements in the Alpine area by accounting actually for the interplay of those different impact drivers. In this study, we focused on this area, as you can see it here. In this picture, 450,000 square kilometers, so quite big area. And we created 3 different models for different movement types. So we focused on precipitation-induced slide types, so landslides, debris flows, and rock falls, always through the lens that they cause damage on infrastructure. Very briefly to the workflow we applied, we first delineated the entire area into almost 18,000 so-called slope units, as you can see one here in the picture. And then within each of those single units, so within each of those units, we mapped potential process areas for each process type to focus our modeling on the relevant terrain within each of those basins. So, and then within each of those areas, you can see them here, the example for rockfall, for instance, for this basin. Within each of these process areas, we started extracting potentially influencing factors for landslide impact, as for instance, of course, morphometry. What are the slope angles in these areas within our basin? What is the topographic wetness index? What is the land cover? What is the lithology, so the geology? And we also used information on potentially exposed assets. So what are the number of potentially exposed buildings in this area? What is the transport infrastructure about? And of course, since we are working in the domain of rainfall-induced landslides, we also had a look at different weather variables from reanalysis data. So different kinds of precipitation variables, short-term precipitation, antecedent precipitation variables, temperature variables, and so on. And then we set up a supervised classifier. So we used the generalized additive mixed models, which in principle linked available impact data, damage data of past damage causing landslides to data representing those impact drivers. So the principle is the following: the potential of an impact in an area at a certain day is modeled as a function of the weather conditions, antecedent weather, current weather, geo-environmental factor, and exposure variables. So in the end, what we did is we had more than 4,000 damage observations, so recorded damage due to mass movements, and we used these generalized additive mixed models to link it with variables describing these driving factors. And in the end, what the model gives us is a probability score that provides us an estimate on typical or untypical conditions for an impact on a certain day in a certain basin. And of course, we went also into evaluating our results from a quantitative performance viewpoint, but also from a qualitative perspective. We have heard before in the talk about trust plausibility and stuff like that. And I think we also went a bit in this direction, and we want to further move in this direction also in the future. So coming to the results, more to the quantitative perspective now, we did some k-fold cross-validation, and we saw for the slide types and the flow type models, which reacted strongly on our short-term precipitation variables as expected. They had a quite high model performance, so our scores above 0.85. And as expected, also for the rock fall models, we got less or a lower performance, so still acceptable, let's say. As expected, rock falls reacted less sensitively to precipitation variability in this case. When we talk about interpretation, so explainable machine learning, we also had a look at partial effects, permutation-based importance. I will not go into detail here, but in summary, as you can imagine, that what the model did is that it modeled the probability of an impact within a certain basin to be higher if we have had many buildings or lots of exposure in those brownish areas, in areas located in or in landslide prone areas. So we had a look there at the topography, land cover, and so on. From a time perspective, on a day with high precipitation amounts, and on a day with certain preparatory antecedent weather conditions, so antecedent precipitation amounts as a proxy for soil moisture, seasonal effects, and so on. What for? Yeah, two application possibilities. We got predictions at a daily scale that might be useful for impact-based warning. And what I show you now in this upcoming animation is a map with probability scores from dark or from green to white. And green means actually the conditions are quite similar to past impact conditions, and white means low similarity to past impact conditions. And this is how such a model or a hindcast event looks like for at a daily scale. So here we have the days, and end of October, we had thousands of damage-causing landslides in this area. And we see how the model reacts in response to short-term precipitation, antecedent precipitation, and behind the model are also lots of information on topography, exposure, and so on. Second application possibility is looking more into the long-term perspective, so going towards a trend analysis to investigate the evolution of critical conditions over longer time periods. So in this case, we had a look at each single basin. So you see a zoom in here. And what we looked at, we ran it for 16 years of daily hindcast, so almost 6,000 days. And we simply had a look if we found over time a positive trend in the critical conditions or a negative trend in those critical conditions. And actually, these are results. So what we see here is in these blackish, reddish colors, we see an increase in critical conditions in several areas. So what we see here is actually changes in the critical conditions due to meteorological drivers. So this was the only dynamic parameter in this model. So not exposure, for instance. This was considered static, which is also a point for discussion, of course. But this is through the lens of climate change, let's call it like that. And we also found some areas where we have a significant decrease of those critical conditions over longer time periods.
Stefan, you have 1 minute.
Yeah, and I'm already at the summary. What we have seen, or what we have produced, is a set of well-performing mass movement impact-based models at the alpine scale. And we see it more like, in our case, as a proof of concept that allowed us to integrate weather, geo-environmental conditions, and exposure. What we try to do is to have still a relatively generalized landscape representation. So we looked at the basin scale representation of the landscape. So one value per day per basin. Still, the modeling behind focuses on this relevant terrain, so on these process areas within each basin. And we saw that this is quite important to avoid trivial predictions in our classification. We also aim to deliver explainable outputs for us internally to also check the plausibility of what our model produced. And also later on, when we want to go towards integrating those models into decision-making, also, of course, to communicate results. Further refinements are definitely needed, also in our case. But we see application potential for, as explained before, impact-based warning. So here you have, again, this hindcast example, and also for climate impact assessment. And the last point, so the next step in our case is that we now, based on this proof of concept, we now started a new project where we want to get serious for a national scale Austrian study, where we want to do similar stuff with better data, of course, better validation, still also including forecasters or warning people in the entire development procedure, if it makes sense for them. If they would trust this model, probably is also models and their decision thresholds. So topics like that we will tackle, and we will go beyond landslides. So also flash flood impact and hail impact will be a topic on that.
Wonderful.
That's it.
Wonderful. Thank you so much, Stefan. We have some great questions rolling into the chat. So I will privilege them over anything I have. We have a couple minutes here. And of course, I brought my wrong glasses, so I can only see a little bit. So Jelmer has a question, says, thanks for the very interesting work. What would still need to fall into place before operational uptake of the models, not just technological, but perhaps also organizational?
Oh, yeah. So one thing we recognized already internally in-house is with our forecasters, they are used to methodological, so to interpreting nowcasting or methodological weather forecast. And if we confront them with such a model, it's rather, yeah, they are not used to such information. So I think lots of communication is still needed to probably convince them, or that they at some point see the advantage or the added value of having such information also available. And of course, just from more technical viewpoint, these are now relative probability scores that would need to be translated into decision thresholds, for instance. And I think here is also co-development needed. So I would not do it by myself and say this is the perfect threshold for each purpose. And another thing which we will tackle also is that these models are trained on reanalysis data, for instance. However, if you want to run it reanalysis data in our case may differ, may have bias or systematic differences compared to nowcasting data, which we use for forecasting. So you somehow need to align those biases as well. So I think these are some points.
Okay, fantastic. All right, so we are kind of up against time here. There are 3 more questions in the chat though, Stefan. So if you would be willing to go read them and reply to them, maybe another one, since I just saw a new message pop in, that would be fantastic. But really interesting to see all this important work to translate from the forecast to impact-based forecast information. Such an important topic. So thank you very much.
Thank you.
And next, we are going to segue to, and let me do my best to pronounce, Ogunlawan Abayomi. Hopefully I got that somewhat correct. And if not, of course, correct me. He's from the Nigerian Meteorological Agency. And so, Ogunlawan, you can share your screen if you are ready to present.
Okay. Can you see my screen, please?
I can now. Fantastic.
Okay. All right. Good day. Yes. Thank you for the opportunity. So I will be presenting on my topic, which is the enhancement of weather-ready community through an machine learning-enabled early warning system developed in Nigeria. So the overview is that I just want to discuss with you some of the tools, early warning tools we are working on in Nigeria, and which we are also integrating machine learning into the process. Yeah, of course, Nigeria is not an exception in Africa with various challenges in terms of the weather hazards such as flood, storm, heat wave, and drought. And problem is that we have different NWP models that are running, but they are always finding it difficult in terms of the quantitative rainfall forecast. These are part of the existing problem. And also, oftentimes, forecasters are trying hard, to generate a good forecast, but sometimes, in terms of the early warning, getting to the end user, it's always the major challenge, and also technicalities of some of the information being passed also is very, very is challenging as well. Oftentimes, some of this information are poorly communicated because message oftentimes does not go through the forecaster to the end user. There are also middlemen that are in between, and also the communication channels oftentimes are also proving challenging. So we are working on a system which is called Meteorist, and this system has a different component, which we are trying to see how we can use local knowledge in order to downscale, and not only to downscale and to turn our locally observed data, fuse it with NWP model product to see how it can benefit our local environment. And this we try to introduce machine learning into it. And there are different components of this system. We have a data processing and forecasting system which generates a medium range forecasting, and we also have a system that's meant for marine operations. Air quality, there's the air quality component of it. So the good thing about it is that in all of these components, machine learning has been introduced, and the concept is not, because we still have to consider the ethical aspect of the machine learning. So we are not saying that we want to use machine learning to actually replace our forecasters. They are doing wonderfully well. So what we are just trying to do is to complement what they are doing, and also to make the time, to reduce the time they are using in producing some of these products. So those are the kind of ethical thinking behind this system. So this system actually, like I said, ingests ground observation, numerical products, and machine learning is helping in terms of bias correction, forecast fusion. That is, we bring forecast, like a forecast example, and also it helps us in detecting extreme events, because if you cannot do quantitative rainfall forecast, it will be very challenging in terms of doing flood forecasting, either flash flood or the riverine flood. So machine learning has been helping in this aspect. And this system, this is just some of the products from this system. So we have various products from it, such as dust forecast, storm forecast, every rainfall forecast, even flood potential zone forecast. And what we have done with flood potential zone forecast is to see is to combine the quantities of the soil moisture with the expected rainfall amounts. Then we are able to tell if there's possibility for a flood or flash flood in any particular location. So in terms of of course, when the forecasts are ready, after machine learning has been used in order to improve the forecast into a locally usable forecast, so we need to find a way to disseminate it. So there are different ways we disseminate. We are directly from this same system. We use SMS, we use mobile applications, email also is being utilized. Then we also have the web dashboard. As you can see on the screen, this is a web dashboard or platform where anyone can access to see the output for on daily basis. And of course, this is a email messages. So we have the nowcasting system as well, which I wanted to introduce. So this actually uses convolutional neural network to detect storm area, and then able to generate message almost instantly that can be emailed to any relevant authorities, so that this message gets to the local authority in time. And this is just an example of the kind of message being generated automatically from the system, from the storm tracking system. And because of the issue of feedback, because we need feedback loop from the end user as well in order to see whether the system, the product are being useful, or maybe they are very useful to them. So not only that we are passing this information through mobile platform, also we have an app that has the capability to also for the user to also send back some of the feedback from the feed. And of course, the times of the trustworthiness of the AI or machine learning approach you are using in order to generate your product, what is most important, as earlier discussed, is performance, because performance will make your system to be trusted if it is consistent. So the performance needs to be consistent as well. So we are in that regard. What we do is that we always validate our high impact events. whenever there is flood, we try to see if the model is able to actually capture it. And this is just a case study where the model was able to capture the events 24 hours before the flood happened. And this is another case of a heat wave over a state in Nigeria, which has been highlighted few days before the event happened. Unfortunately, is another thing to pass the information is a different thing for people to act upon that information. Unfortunately, around 200 people, died as a result of the heat wave in that location, but the forecast was there and was actually disseminated. So in conclusion, this kind of project, which involve machine learning and local knowledge in terms of downscaling, is a very good tool for nations, most especially in Africa, where there are challenges with data and challenges with a model being able to capture the event, the global models. So this kind of a low-cost tool can actually help, and is scalable because it can be adopted in any area within Africa or any other places. So thank you for the opportunity. Yeah.
That was just wonderful. Thank you so much. We are already getting some questions in the chat. I will read them. So Dave Jones says, great presentation, thank you. Do you have any challenges with people knowing where they live on a map? Geographical location seems to be a challenge everywhere.
Sorry, can you come again with the question?
So Dave wants to know do you have any challenges with people knowing where they live on a map? Because sometimes that's challenging for people to know where they are.
And because we work with the local authorities as well in disseminating the information, that is not a challenge. Whenever the information is transmitted, they already know where their area is, because Nigeria has several states and regions. Thank you.
Okay. Can you also stop sharing your screen right now, Okunlawan? That would help, because I think we're getting what's called an infinity mirror. Okay, fantastic. That way we can see you better too. All right, things are jumping around here. Let me go down. So Carly says, great talk. The capability of the tool to accept end user feedback is really interesting. Can you talk a little bit more about the community feedback and how it's used to change or improve the development?
Okay, one thing we are interested in terms of the feedback is that, because in the 4 pillar of the early warning system, also there is a knowledge. The first pillar is a knowledge, like knowing the hazard area and the vulnerable area. So we want to know, we want to get this feedback and information from people that whenever there is an event in a location, they are reporting this information in real time. So when this is done, we go back to the model to see whether the model is able to perform. So it's in kind of evaluation approach.
All right, sorry, I'm trying to manage these things. So Carly and others, if you have additional follow-ups, please feel free to add them in here. Jelmer says, this is great work. How is your experience getting feedback from the public on your warning products? You were kind of touching about this. Is it just through the app or also through other venues like WhatsApp or other channels?
Yeah, presently, because it's only the app that they are using to report. And it's only when so you can't get reports from everybody. So it's only those that are able to give back the information. So, and you only rely on the ones that are available.
Okay, great. I might have a follow-up question. And are you getting feedback from mostly the public or from people in certain sectors? Like you mentioned, I think ag, I'm trying to remember one of the other, like transportation sectors, or is it across all of those?
Yes, because we work with the local authorities. We work with local authorities, so we also get information from local authorities, but oftentimes it's challenging to get from the general public, but especially when they are not properly sensitized as okay, they can transmit this information. Yeah, but majorly from the partners and local authorities.
Okay, fantastic. And then maybe we have at least time for one more question. Great job. What are the next steps? This is from Hugo.
Well, next step is always improvement, because actually no model is 100%. So we have realized the weakness of the model, and we often try to improve it. And part of the improvement we are doing is example, like combining 2 or more models, and also downscaling, coupled with the machine learning approach. Yeah. Thank you.
Okay. Yeah, wonderful. Well, thank you again so much. We are going to now transition to Aaron Evans, who is going to be talking. He's from the University of Albany. He's going to talk about a machine learning for anticipating high-resolution rapid refresh forecast errors. So, Aaron, I see you there. You've got your screen shared. Take it away. I'll start my timer.
Great. Hello, everyone. I'm Aaron Evans, like Julie just said. I'm a PhD candidate at the University of Albany in New York in the United States of America, and I'm going to share a product I've been developing over the past several years. It's a path towards AI-enhanced forecast confidence for NWP end users. So we set out to give NWP end users or forecasters an ability to game the most accurate NWP model for a location, specifically for temperature, precipitation, and wind. We want this to augment a forecaster's ability rather than replace them with a machine learning model. So let's say there's a weather setup and we have our suite of NWP models we typically use. Hopefully the forecaster has an intuition for what a specific setup translates to what the most accurate model is, whether it be a nor'easter or a front. And so using their intuition, they could also run this by a machine learning model and see what NWP model is the most accurate or is predicted to be the most accurate for a location. Let's say that's the HER, because that's what we'll be talking about today. So getting into the data, the high resolution rapid refresh model is really advantageous for ML purposes. It has great temporal and spatial resolution, and it's initialized hourly. So I am using the variables on the right-hand side to make predictions for my model. Next, we have the New York State Mesonet. This is our ground truth, our surface observations. It's a network of 127 sites with an average spacing of about 30 kilometers between sites. We are using the top of our observation for each of the variables listed below, so that way we can match up the resolution with the NWP model, which is the HER in this context. There's 2 exceptions to this. We aggregate precipitation or accumulate precipitation over the hour, and we average the wind speed over the hour. That QR code will take you to the Mesonet website if you're curious about the data, but here's what a standard site looks like with the instrumentation circled. Next, we have microwave radiometers that can profile the planetary boundary layer here in New York. That's done using spectral bands, using oxygen absorption and water vapor. We are using the previous hour of data from these microwave radiometers. We're only going up to 5,000 meters, as that more than encapsulates the mixing layer in New York State. And we're only applying this to New York State Mesonet sites that are within 30 kilometers of one of these profilers, as that allows us to not lose any mesoscale resolution. And again, we're using these variables listed on the right-hand side from the microwave radiometers to train our models. And here is what a profiler site looks like, and I've put a little white rectangle around the microwave radiometer. So we have a suite of models that we've trained that all are advantageous for different purposes in this context. We have our hybrid model, which uses the planetary boundary layer and the surface observations. This model is really advantageous in convective regimes. We have our LSTM model, which is really great at bias correction. So this model is really great at longer lead times and does a great job of predicting the kind of baked in bias within the high resolution rapid refresh model. And lastly, we have a Bayesian neural network. What this model does is it captures the uncertainty in our model's predictions. So it gives a deterministic output, and it also gives a bounded range of where that output might lie, depending on how uncertain or how outside of the training data set the model output is. So again, just to cover this pipeline again, the LSTM uses observations from the ground and the HER, and that's fed to the LSTM, and then we get a deterministic output from there. The microwave radiometer is fed to a vision transformer, which also interacts with the LSTM to give another output. And the Bayesian neural network is fed off of the parameters from the LSTM, and that gives us a deterministic output and a range of uncertainty. So the data that we're about to look at is from 2024 and 2025, but I wanted to show you the range of the training and the validation data set that we used. For this, I wanted to show some case studies of precipitation error, specifically weather events that are well outside of the training data set, kind of pushing our model's capabilities to the extreme. So we can get an idea of how trustworthy this model is and what a failure mode looks like. So we have lake effect snow, we have a 1 in 1,000 year flash flooding event, and we have a high intense mixed p-type. So for the lake effect snow, this took place from January 2024. On the left-hand side, you can see what the MESNet observed, and on the right-hand side, you can see what the HER forecasted. And this is averaged across all 18 hours. Just to highlight the error a little bit more in HER forecast hour, this plot will show you over and under forecasting, where red translates to over and blue translates to under forecasting. So here we can see the actual model output. We're looking at Ontario Station. The top panel, the black line shows you the MESNet observations in millimeter per hour, and the blue line shows you what the HER output. This middle panel is the precipitation error in millimeters per hour. So the black line again is what we're targeting. The red is the hybrid model, the yellow is the LSTM, and the pink is the Bayesian neural network. And then the bottom panel is the same as the top, but we have shaded in the ensemble spread to give you an idea of what we would actually be showing an end user. So the HER root mean squared error in this is 0.71. I'd like to highlight that the hybrid model follows very closely with the target. If you can look this, it's a little bit of a spaghetti line, but the red line follows the target very nicely. And again, 0.45 millimeters per hour, so improving upon the HER. And then if we just take the average of all of our models, we get 0.47. So again, just to reiterate, the hybrid model is very good in convective weather, both cooled and warm convection. So that is where this model is advantageous. Next, I wanted to show the 1 in 1,000 year flash flooding event. This took place in August of 2024. Particularly, it affected Stony Brook. And it also affected areas of Connecticut. And again, just to highlight where the model over and under forecasted, just because it can be kind of hard to tell the difference between those two plots. Blue means under forecast, which means more precipitation occurred than was forecast. And red is over forecast. So the HER was predicting more rain than what occurred. And again, this is averaged across the event here. So again, top panel, the black line is what the MESNet observed. The blue line is what the HER output. The middle line is the forecast error along with our model's output. And the bottom panel is the same as the top, but with the ensemble spread. So all of our models clearly missed this event, and this was a 1 in 1,000 year event as signified by the National Weather Service statistically. The reason I wanted to include this is because the Bayesian neural network captures the uncertainty of this event almost perfectly. Again, it would be up to a forecaster to determine what is going on, but I think this is actionable output to flag that we shouldn't be trusting what's going on with the HER or our models. So again, just to cover the root mean squared error, we have 24 millimeters per hour for the HER. The Bayesian neural network did the best, even though I would classify this as a miss, and we got 19.71 millimeters per hour there. And then the ensemble spread, the average across our model outputs is 23.11 millimeters per hour. Lastly, we have the mixed p-type event that occurred in February of 2025. Again, the left-hand side is what the mesonet observed, and the right-hand side is what the HER was forecasting. And this is averaged across all forecast hours. I think, again, this is nicer. So red is over forecast, which means the HER was saying it was wetter than we anticipated. Blue is under forecast, which means more precipitation occurred than was forecast. So lastly, we have Ellenberg. Again, as with the previous examples, the black is what the mesonet observed, blue is what the HER output. The middle is our model's output for predicted forecast error, and the bottom panel shows the ensemble spread as well as our model output. Here, the LSTM shines. So the LSTM does a great job at bias correction, and the HER in New York State has a particular wet bias at longer lead times, which is really dramatically shown in this figure here. So the yellow line almost perfectly follows the target black line in the middle panel. So the LSTM compared to the HER reduces the millimeters per hour error by 7. And then lastly, the ensemble spread, if you just average all of the model outputs together, we get 1.7 millimeters per hour. So I'd like to acknowledge—
1 minute. Go for
Thank
it.
you.
Beautifully timed. Yes, 1 minute.
I'd like to acknowledge that this work was funded by AI2ES, and I'd also like to acknowledge that this work is made possible by the New York State Mesonet. If you want to contact me or look at my code, you can take a screenshot of this, and that QR code is just my business card. And with that, I will stop sharing.
Wonderful. I always try to time when to jump in, but I should have just let you wrap things up beautifully. You timed this wonderfully. All right, we are getting some questions coming into the chat. So Chris says, great talk, Aaron. Very cool stuff. We've heard from forecasters that as there are more and more models and updates being made, it gets hard to track how each of them perform in their areas. How could this work scale to address more models or model updates and do this for more areas? What would we need to do to make that happen?
Yeah, thanks for the question, Chris. So we've also applied this work to the Oklahoma State Mesonet. I will say that the model does a much more better job in Oklahoma. That is due to the HER just being more accurate in Oklahoma, I think. So it has more to go off of. Oklahoma is also a much more homogeneous domain as compared to New York State. The land use land class is pretty stratified and consistent, and it's very flat topographically. I will say that we have tried this on other NWP models. The more fine resolution the NWP models, the better it is. So anything greater than 15 kilometers, I would say we start getting less usable output. Another thing that I would say is a limitation to this model is if the NWP model or whatever model you're using undergoes a very drastic change in its parameterization, is a statistically significant change in its deterministic output, our model would need some time to catch up on that, probably 6 months to a year. So that's something that I think people need to keep in mind. Part of the reason why I chose the HER is because it's starting to be sunset, so it's stuck. It's kind of in a finite form right now. So it's a really easy model to play around with. Yeah.
Thank you. Jelmer has a question. How do you discuss these outcomes with operational forecasters? What kind of feedback concerning confidence/trust, we're going to use all the words, are you looking for?
So one of my advisors runs the State Weather Risk Communication Center here in New York. So he's been integral to helping us develop this product. What kind of feedback concerning confidence and trust are you looking for? I mean, I would want someone to feel confident in using this product, but I feel more so that I would want them to have the guardrails in place to know when the model is and isn't trustworthy, if that makes sense. So on one hand, I would like them to use it, and on the other hand, I would like feedback on how and when and why they're using a model like this, if that answers your question.
And Jelmer, please feel free to follow up if you have follow-ups. Going back to the first answer to that question, the answer to the first question from Jelmer. So you said you're working with somebody who is kind of running the state weather risk communication, and they're kind of helping with forecaster feedback. Have you been involved in any of that directly? Are they putting the model in front of forecasters kind of, outside of main operations to help them see this, or in operations or in other maybe more formal settings to get feedback?
We kind of ran out of funding to start doing social science with this project. So unfortunately, it's really just been working with that group specifically rather than forecasters. Yeah.
Great, thank you, Erin. I have another question while we are, actually, Okenlau, and you put your camera, okay, I just wanted to make sure. Sometimes that's an indication that people have questions. I have another question, Erin. When you were showing the mixed p-type, and forgive me if I missed this, it was just primarily the amount of mixed p-type, or is it also able to discern what the actual mixed p-type is?
Yeah, great question. So our model does liquid water equivalent predictions. So we're not predicting the actual p-type itself. But in New York State, in those transition zones, knowing the amount of liquid water is really helpful to determine the damage that the storm might cause. Yeah.
Wonderful, great. All right, well, I think with that, we are going to segue to last, but certainly not least in our session, Carly Sutter, who is also from the University of Albany. And Carly's going to be talking about co-production, co-development. Sorry, I said co-production. I should have said co-development, Carly. So take it away.
Great, thanks. Can you hear me and see my screen? Perfect. Okay, great. So my name's Carly Sutter. I'm a PhD candidate at SUNY Albany, and I'll be talking about a portion of my dissertation research, which is about the co-development of a machine learning decision support tool that we build with the New York State Department of Transportation. And throughout this talk, I'll refer to them as New York State DOT or DOT. I'd like to thank my committee members and then also the DOT who we wouldn't be able to do this work without them. So to introduce this problem, as I'm sure many of us are aware, hazardous weather impacts traveler safety. And so I have two examples shown here on the right, poor visibility and snow. And so DOTs have to manage thousands of miles of roads during these extreme events. So managing things like salting, pre-treating, snow plowing. And these operational decisions are really time sensitive and may change frequently over the entire state, over a large region. So then where does AI fit in? So at UAlbany, we've been developing a machine learning model to detect weather-related road surface conditions using camera images and weather data. And so the benefits of building a tool like this is that it can make frequent updates, which is really important because you can see snow accumulation here on the left with these two images just 5 minutes apart. And the tool can cover a large spatial area and also make predictions at the granular level. And so all those things sort of align with the operational applicability. And so a little bit more about where the road surface conditions come from. So we have to teach the model what severe snow or wet looks like. And so for that, we need a labeled data set, which we developed by observing thousands of camera images and hand labeling them following a social science method that Chris Weaher talked about in his keynote talk, known as quantitative content analysis. And so we have 6 classes. Those are shown here: severe snow, snow, wet, dry, poor visibility, and obstructed. And this labeled data set serves as the ground truth of what's happening on the roadways, and we use it for model training. So in terms of the data that we're using for the model, we have 3 types of data. So we have the image data itself, so the images. We have weather data, and for this we're using her forecast hour 2 data, which is valid at the time of the image. So we co-locate in time and space. And then we also have the labeled data, which I talked about in the previous slide. So our 6 classes. And so the images and the weather data serve as inputs for our model. And then the output is our road surface condition classification. And I want to mention that we have 2 functionalities. So this is representing our nowcasting tool. We also have a forecasting tool, and for that, we wouldn't have an image for the future yet. And so for that, we just use the weather data as inputs to our model. And then just to ensure that this tool is really operationally effective, the model can't just memorize specific cameras. So we utilized a nested cross-validation approach to ensure that the model generalizes to new locations that it's never seen before. So building a generalizable model was a really big focus of this work. And so our nowcasting model performs at about 82% accurate, and our forecasting skill is 70 to 74, but depending on how far out we're looking. While assessing this model skill is really important, a really important step, obviously, of the model development process, it's just one piece of the puzzle. It's not really alone. It's not alone is not really enough for operational use. And there's been tons of research done around trust in AI, AI ML tools, 3 of them shown here, that really show that incorporating end users into this process is critical for effective delivery. So because this work is really at the like an application that's at the intersection of weather and AI and transportation, it's been critical throughout this whole process that we work with our transportation experts. And so for that, we've really relied on interdisciplinary collaboration with social scientists. So we've taken an iterative and cyclical approach kind of through all steps of this process, from the early phases with the data set curation and labeling, which I talked about earlier, to model development. And then most recently with developing a tool, which is a visualization dashboard that displays model outputs, mimicking what a final tool would look like for them. And an example of that is shown here on the right. And this last phase in blue, this tool development, and showing our tool to the end users, the DOT, and interviews is what I'd like to focus the remainder of this talk on. So we did these interviews to understand how users perceive and assess and trust our tool, and also how they, what are their needs and expectations. So myself and Chris Weaher, who is the keynote speaker, have conducted 10 hours of interviews with 15 individual New York State DOT employees whose jobs revolve around winter weather operations. We did this about a year ago. And our interviews were semi-structured with open-ended questions. So this just means we had like a core set of questions, but we allowed the conversation to really flow naturally based on the participants' answers. That way we could capture the nuances of their experiences and perspectives. And then in terms of the analysis, so our interview data is descriptive and qualitative. So the data is the actual language and explanations from our participants, stories they shared. So to analyze this, we use thematic coding, which we can just think about as organizing the data into buckets based on recurring themes that we hear in the interviews. And we do this iteratively until we kind of come up with our final set of themes and takeaways representing what we heard in the interviews. So now getting into the results from our interviews, I'd like to, of course, say that this is just our specific New York State DOT end users. The sample of people that we interviewed doesn't speak for all transportation officials, of course. But the first takeaway that we saw was that DOT end users express varying levels of eagerness towards AI and machine learning. So some are really eager, some are more cautious. But something that we saw, despite where they fell in this eagerness range, everyone emphasizes the importance of human oversight. So this longer quote here is what I'll focus on. So one user says, "It sounds like you're teaching the machine and AI machine learning how to use the data. And obviously with the oversight of a human, I think it's a very interesting tool that can be used in the future." So I think that kind of emphasizes this theme that we saw really well. The second takeaway was that users really take a hands-on approach and rely on the tool used in order to both understand and evaluate what the tool can do and its capabilities, and also for assessing the trust in the tool. So I do have some quotes here, but this was something that we mostly observed during the interviews when we handed over the tool to them to use. Users often take a spot checking approach to sort of zoom into a local or recent event that they're really familiar with in order to sort of like verify and learn what the tool can do and how good it is. And then that theme sort of popped up again in terms of how well they trusted the tool. So users really emphasize the need to get experience with the tool and use it over time to give it a high trust ranking. But overall, we did ask them to rank their trust in the tool, and we were about a 5.5 average or 6 median overall. And then the third major takeaway was that we were able to gather what users found most helpful, and then also gaps or further expectations. So in terms of the usefulness, showing where the storm is and is not was really helpful to users. And this was specifically for resource allocation. So by having this big regional view, they can help them view and plan for resource allocation across or within regions, also with route optimization and staffing. And then the forecasting capability, users saw usability with both the forecasting and nowcasting, but the forecasting feature was something that we built in, that we heard really early on in not with these interviews, but in our collaboration with them, that forecasting is really important. So we've added that in as well. And then gaps and further needs of the tool. So users are really curious and they want to learn more about machine learning, clarity on definitions, having all that stuff sort of in the tool so the users can dig in as much as they want. Users had specific interface or visualization needs, like adding in traffic speeds or the raw camera images themselves. And then also more complex asks, so things like extending the forecast feature, including model confidence or other types of models in there as well. And so how does this interview process really help? So like, what can we actually do with the qualitative information that we learned from the interviews? Well, with the previous slide, with the gaps that we identified, this can really help us as developers sort of triage what is important to focus on based on like what the users talk about as need things that they really need. We also found overall that no two users really share the exact same perspective. So as a developer, that can sound kind of overwhelming because there's really not a one-size-fits-all approach, but sort of building in flexible features that allow users to choose how and what they want to see is really important. And then this idea that trust is really built through use and experience, which is what we saw. And so this really emphasizes the need for continued collaboration. Like you can't just, achieve trust in this set of interviews and be done with it. Users want to use it over time and assess the tool.
Carly, you have 1 minute, just so you know.
Great, thanks. So just to kind of conclude here, so we've taken sort of this complex problem that's at the intersection of AI and weather and transportation, and we've really focused on collaboration between developers and social scientists and end users to create this tool for road weather decision making for the DOT to use. We have a manuscript in preparation for this interview-related work, and then for our machine learning model that's accepted and is available in preprint as well. And feel free to reach out to me here at the bottom. And thanks for the funding, which is the AI2ES through NSF.
Wonderful. Thank you. And there goes my timer right there. I have all sorts of questions. Okay, actually, I see them popping in, so I will hold mine. So Aaron says, great talk, Carly. Could you talk a little bit more about this feedback loop and how it's used to change/improve aspects from the development side?
Yeah. So let me go back here. So we don't have the feedback built into the tool right now, but this feedback through the interview process. What we can do with that is focus on the things that we heard most frequently in the interviews. So there's really simple things like, visualization features or like adding in road labels like I-90 here. And then that was kind of a common theme that we heard. But then users also, a big theme that we heard was that users wanted model confidence to be included in the tool as well. So not just our prediction, but how confident we were in, or how confident the model is in its prediction as well. And so that was a really big thing to add in there too. But because we heard that mention of model confidence, maybe like 11 out of 15 times in the interviews, I can't remember exactly how much it was. It helps the developer know what to focus on. That's a really big aspect as opposed to maybe the list of 30 other things that people just mention in passing.
Wonderful. I have all sorts of follow-ups, but here we've got great comments coming into the chat. So Jelmer says, thanks for the talk, Carly. In your interviews with DOT operators, did you notice any differences in willingness to adopt or trust AI tools according to their career stage or age?
Yeah, definitely. Some folks had mentioned, maybe the next generation would really love this, or I trust myself more than I trust the machine, and things like this. So we definitely see a little bit of that, but I think it really depends. I think a lot of people just talked about wanting to use it. That was kind of more of a theme than like a strict sort of age or stage kind of takeaway. Yeah.
Great. Hugo says, good work. One question, could including weather station data improve the score?
Yeah, I think so. Yeah. So we decided to use her data just because of its small spatial grid. We do have New York State Mesonet data, which Aaron talked about in the previous talk, but those were a larger distance from our camera sites. So we just wanted to use the her data because it has, kind of equal coverage everywhere. But I think including observational data would be helpful. Yeah.
Okay, great. Chris Davis says a long-standing problem is discriminating fog versus snow with automated surface stations and cameras. How does your model make that distinction with confidence? Did this issue come up with the users?
Yeah, that's a great question. And this kind of gets back to our labeling process. Because I mean, you can kind of see here in the severe snow versus the poor visibility example, it looks really, really similar at quick glance. So we came up with our code book that Chris Words had talked about a bit too, a really long, detailed list of what and examples and rules of what constitutes severe snow versus poor visibility. And so for us, poor visibility meant you can't really see the road itself, but you can tell that there's some sort of visibility obstruction. And so in some cases that might have been severe snow, but if you can't see the road to say it's severely covered with snow, you would label it as poor visibility. So that's just sort of one example. But yeah, this was something that was important to us and the end users. And then in terms of model performance, I don't remember off the top of my head if our models were kind of like more less confident in those sort of in-between cases. Probably so, but that would be a great thing to look into. Yeah.
All right, we're going to round this out with Mickey's final comment here. Mickey Olson says, Carly, I really appreciate how thoughtfully you incorporated end users through the entire process. Did any participants express concerns or have questions about your quantitative content analysis of the images? So rather than talking about the model, did they want to know about the social science components?
Yeah, it's a great question. So when we developed the codebook for labeling, we did work with the end users, DOT, at that process. So that was before these interviews that we talked about. It was really early on in the phase in the data development. But then when it came to the interview time, not all of those people were necessarily involved in, the questions that we asked during the data set curation. And so those are the types of people that asked, oh, can you please put more information in the tool you've built about what does poor visibility mean? And so adding in those definitions of the classes into the dashboard is something we need to do and came up a lot in interviews. Yeah.
Wonderful. There's another comment from Philippe, questions in the chat, so maybe you can address that, but we are at 35 after. I would say we rocked it with the keynote, with this first session with the speakers. They all were perfectly on time. So Thomas and Miranda and Sally, you have pressure on after we come back from the break. And with that, we are going to take a break and we will all be back at 45 after the hour. So thank you, everyone.
Okay. Yes. So welcome back, everybody. It's time to start with the next part of our session. We've had some great presentations already, and I think very engaging discussions, both live and in the chat. So I hope we can continue along that route for this session. Yes, we start off with a little bit of a new theme. It's been discussed already previously a little bit as well, topics around trustworthiness, but also moving it a little bit more to towards the end user space and how people actually relate to using AI-based products and what they are basically expecting related to, for example, personalization and also more specific types of products. So this is something that we are going to look into with 3 presentations. The first one is from Thomas Cox from the Weizenbaum Institute in Germany, and he is going to talk about people's hopes and concerns regarding AI and weather warning systems. So, Thomas, I see you are sharing your screen. The floor is yours.
Thank you very much, Jelmer, and good morning, evening, or good day to every one of you. So I will present a paper written with some co-workers. One of them is also here in this meeting, Sarah Harrison, who was doing a fellowship at our institute at that time, and so I will pick up some parts of topics which already have been discussed today. And so our motivation for our study was that we see a lot of more generalized hopes regarding AI in the improvement of accuracy, speed, forecast warnings in general. But we also have we can read a lot about concerns about the introduction of AI in, for example, critical decision-making situations. And we already heard about the role of human oversight. And more specific, some people argue that there is a fear of that human labor could be replaced by artificial intelligence. And while we thought about this, there's actually quite little attention paid in science to the views of those people who are involved in creating the warnings, using the warnings, and applying them, and with obviously a notable exception, and those papers already have been mentioned today as well. So our question was, what actually are the hopes and concerns of the weather warning community? And to do that, we used a method called Delphi, or more specific, we used an argumentative Delphi method. Delphi is an estimation method for a systematic multi-stage survey to assess trends, technical developments, and furthermore. And one of the most important things to know is that it works with feedback. So we use a group of experts. They are presented with a question of topics, and then they provide us their insights. And it has multiple rounds, so the feedback is provided, and they have the opportunity to respond. This is quite actually a good method to counteract specific group dynamics. You all know about that in meetings. There are sometimes very dominant individuals, and so this is an opportunity to let everybody speak and have their views. So where do we find those experts from the weather community? So we used a conference that happened in 2024 in Munich, the WNO High Impact Weather Final Conference. We asked the participants if they want to join. 19 of them stayed until the end of all rounds, 2 rounds of the expert survey. They came from all over the world, mostly with a background in meteorology, but also some of them in social science or behavioral science. So I don't want to go much into the detail about the methodology of this study, but I will provide you with an overview of the aspects we discussed. So what you can see here is the range of like 13 different aspects that were outlined in the survey. And every time the participants will ask what they might think in the next decade an AI-driven warning system will have an effect on these aspects. So they had to rate if it has a positive, a negative, or no effect on these aspects, and then they had to provide an argument for their assessment. And the argument was what we were really interested in, and that was something that we wanted to see. So some of the aspects are about more coming from a methodological perspective, so quality, consistency question, value questions, but some more on the use, interpretability, acceptability, but also aspects that were already discussed today: accountability, biases, human involvement, and so on. So to not show you like all the 13 aspects, that would take too much time. I just want to say give you a broad overview. So overall, the participants expressed quite positive expectations regarding the use of AI, especially in terms of this economic value, quality, and both internal and external consistency. But we saw also some mixed expectations, mostly about the relationship between public and private warning services and about the role of the human within the warning system. And when we look at the arguments they provided, and I don't provide any quotes here, but so if you're interested, please have a look at the paper in the supplement material there. So most of the arguments towards improvements are, for example, about faster, more accurate, more localized warnings, shorter lead times, and especially in complex and in rapidly evolving situations. And they mostly focus around the aspects of quality, internal consistency, and again, the economic value. If we look on this other side to the concerns, they mostly relate to questions about accountability, but also about quality and external consistency, and as I already said, about the relationship between public and private warning services. And here, for example, one very strongly argumented topic was the loss or the fear, the concern of the loss of an authoritative voice. So that, for example, the issue that AI promotes multiple and different providers with different types of messages, and that could cause confusion among those who receive the warning. So if you want to look into like more on these arguments and on the assessments, please have a look in the paper. I will try to use my last 3 minutes on 3 of the key issues we identified. It's something we call the goodness spillover effect, issues around tailoring of warnings, and finally the question: is AI seen as a decision-making aid or support, or a decision-making support tool? So what we understand with this goodness spillover effect. So what we could see is that there is a strong interdependencies between arguments regarding the quality of the warning and the acceptance and the responsibility of the warning and the warning provider. And what we can see is that these improvements are primarily seen as data-driven, which is not really surprising, as this are the effects that we consider are those which are most in the hands of, for example, a meteorologist, is the quality of the warning. But on the other side, acceptance and responsibility is something which is more seen outside of their scope. When we look into tailoring, we could see that the survey participants believe that AI will enable or promote tailoring of weather warnings. What are the arguments behind that? It's AI is seen as a way to reach a larger audience and thus increase the value of a warning. Furthermore, it's assumed that AI is capable of reducing inequalities, also something we already heard today, if, for example, data on vulnerability is included. However, if this vulnerability data is biased or incomplete, AI may also perpetuate inequality. So what we can see is that human knowledge about the warning users and the judgment about whether to issue a warning or not are seen as fundamental in the introduction of AI in warning systems. And so what we can see actually is that AI increases the need for human involvement in a warning. So that brings us finally to the decision, like, is AI seen as a decision maker or as a decision support tool? And here it's participants argue that AI can contribute to the warning process either as a decision support tool to enable the human to concentrate on some more important aspects of the warning, and on the other side also to help automating maybe parts of decision-making processes that allow for correcting any bias introduced by the human. And I already saw that in one of the comments today as well. So quite interesting, no concerns were expressed about any uncritical acceptance for automated decisions. That was not a concern that the experts have seen. However, and that's something I want to close with, is what we saw as some final remarks. What we could observe in the study was that while we're following the discussion, the issue of automated decision-making seen as touching something, what we call like the professional core of weather warning as a profession. So it quite was interesting to see that in the way the discussion about AI-based warning systems have triggered something, a process of self-reflection, self-assurance about what it actually means to be an expert in the field of weather warning. So if you want to read more about this, have a look at the paper, and I'm happy to answer any questions. Thank you.
Thanks a lot, Thomas, for this very interesting presentation. A very a reflective angle towards AI developments. So yeah, please write your questions in the chat. I see there's a few already written there. The first one coming from Philip Bukowski. He says, "Hi Thomas, thanks for your presentation. Do you believe that AI fragmentation of use leads to too many inputs for warning consideration? For example, one AI for flood aspects accounting, another for windrow and roads, another for energy systems, so that it starts ballooning basically."
That's a good point. I'm not sure if I can answer this with yes or no, but I think it's quite interesting to think about that. Like, do you mean it for like somebody seeing the AI output as I said, a decision support to make to come to a final decision to, for example, issue a warning, or is it something someone would read? So like without any forecaster or something in between. I think that's a huge difference.
Yeah, thanks. So I don't know, Philip, if you're happy with that answer, but feel free to also follow up in the chat. Julie has a question. Was there any concern voiced about internal consistency within data-driven AI models? For example, within model fields, different layers between input and output, these kind of aspects.
Oh, good question. I would need to look into the data again. I'm not sure. Like not that I know for now. I would have to look into if there would. So like we had the arguments, and then we asked the participants to rate. So at the end, so the method is working towards a consensus. So what we want to see is that what's the most striking argument. So there might be some argumentation going in this direction, but that's nothing we really picked up, which was very prominent in the discussion.
Okay, I think there's time for one more question, and it's coming from Christopher, and he's asking something about the sample. Was it international? Did you notice any differences or similarities across countries?
Yeah, good question. So it was international. We were lacking people from Asia, unfortunately, but there were participants from Africa, from Europe, from the Americas. I'm from Australia and New Zealand region. But we didn't see any differences. We looked into it, but no, not regarding the assessment, and certainly not with regard to the argumentation.
Okay. Thanks so much, Thomas. I would be really interested to see if there's an opportunity to do this kind of study again, maybe in a few years from now, to see what kind of changes are emerging if the field has been developing.
Certainly.
Thanks a lot.
Yeah.
Yeah.
Thank you very much.
So we're going to move on. And now we move back to the US. Miranda White from Texas A&M University is going to give a presentation about how decision makers trust and use machine learning predictions for managing marine cold stunning event risks. So Miranda, I see you are sharing your screen. The floor is yours.
Awesome. Thank you so much. Again, my name is Miranda White. I'm a PhD candidate at Texas A&M Corpus Christi. Today, I'm going to be talking about my research titled How Decision Makers Trust and Use Machine Learning Predictions for Managing Cold Stunning Risks. So as hazardous weather events intensify, there's a growing demand for reliable science-informed tools that can guide decision makers, managers, and economic operators in how to respond to both current and future threats. While scientific knowledge is essential, decades of research show that producing the science alone is not really enough for effective decision-making and fostering that trust within these tools. So to be effective, some of the messages that you've heard throughout this conference is that scientific tools must be developed with a clear understanding of who is using them, why, and under what decision contexts, especially when managing complex multidimensional risks. So AI and machine learning models are increasingly used across environmental forecasting, from severe weather and coastal flooding to water temperature predictions. And these models also show really strong potentials as decision support tools as well. However, as their use and popularity has increased, so have questions about how they're perceived, trusted, and relied upon, particularly in high-pressured, time-sensitive operational settings. So to examine trust and interpretation in a real operational context, this study focuses on machine learning-based water temperature predictions used to support management of cold stunning events along the southern Texas coast. And so for over 15 years, there's a deterministic machine learning model developed by Texas A&M University Corpus Christi's Conrad Blucher Institute that has been used to communicate when critical temperature thresholds may be reached. And this information is shared with a very diverse multi-domain stakeholder network, the Texas Marine Cold Water Response Collaborative, tasked with managing ecological and economic impacts during these cold stunning events. So to explore these dynamics, this study draws on interviews with key decision makers to examine how they're perceiving and using model-derived predictions within their operational context. So we asked these three main research questions, but today I'm going to only be focusing on that last one there that states, how do users perceive the trustworthiness and usability of this information in supporting effective environmental management? So to address these research questions, I developed a structured interview protocol with approximately 25 questions designed to elicit how users are assessing, interpreting, and trusting cold stunning predictive information. And I conducted 14 interviews with stakeholders across the collaborative who hold different roles during cold stunning events, including natural resource managers, forecasters, and coastal economic operators as well. This really allowed us to capture a more holistic view of how decision-making is unfolding across the collaborative, and not just from one perspective, but across the full response system. And then the second and primary portion of each interview was an interactive cold stunning simulation. So participants were navigating a slide deck containing predictive panels with very familiar operational information, which included the deterministic machine learning water temperature, air forecasts, along with air temperature forecasts. Also an ensemble air temperature prediction used in practice to inform cold stunning preparedness within this collaborative. So as participants were clicking through these panels, as you can see, they were asked to think out loud while interpreting the forecast, using a short checklist to guide their assessment that you see to the right there. And this approach really allowed us to observe how users are interpreting, trusting, and using this predictive information in real time, rather than just relying on retrospective descriptions. And then participants first reviewed those practice panels on that last slide to become a bit more familiar and comfortable with the layout and content of the activity. Then they moved into the main simulation where they were assessing forecast information across 4 key time periods leading up to a hypothetical cold stunning event. And at each stage, we asked about the perceived likelihood, the timing, potential severity, trust in the information, and then how they would use it operationally. Importantly, all of the findings that I'm going to show next are derived from the simulation activity, which allow us to examine how perceptions and trust evolve as the threat becomes a bit more imminent. So starting at the 7-day time marker, 7 days out from the cold stunning event, the stage actually functioned as a practice example. So we focus here on just sense making rather than trust. So digging into the results very quickly, during this early monitoring phase, natural resource managers and coastal economic operators primarily relied on the deterministic machine learning water temperature predictions to assess whether the conditions were approaching these decision relevant thresholds that you see in the dotted lines there. Air temperature forecasts, particularly the probabilistic forecasts, were more so used to add contextual information to build situational awareness rather than to prompt immediate action. So at this stage, many natural resource managers and coastal economic operators perceived the likelihood of the event as low, largely because the water temperatures were still well above the threshold, even at longer lead times. So in contrast, forecasters were a bit more comfortable interpreting the probabilistic air temperature forecasts, using longer lead time uncertainty information to refine their mental models when other guidance was unavailable, especially for longer lead time predictions. Overall, this stage is highlighting how different users are prioritizing different information sources. So this is really setting the foundation for how trust and usability are evolving as the event becomes a bit more imminent. So by 4 days out, we're getting closer to this event here. The engagement with the predictive information increased across all user groups. So this shift was mostly driven by 2 key signals here. First, we see that the predictions are now crossing below decision relevant thresholds, and also the increasing agreement across the models. At this point, most users are shifting away from asking if the event would occur toward when it would begin and how long is it going to last. This information was then actively used, and our users were vocalizing that it would be used to support domain-specific planning, such as preparing search and rescue operations for sea turtles, coordinating fish kill assessments, and then pausing coastal economic activity, and even continued dissemination of weather guidance from our forecasters. Now we get to talk about trust now at 4 days out. At 4 days out, trust in the predictive information was very high amongst most users, but more importantly, for very different reasons across our domains. Many users grounded their trust in the past experience and familiarity with the models themselves, with the developers, and then with how those developers were interpreting the outputs for them. So for long-standing members of the collaborative, this history then translated into confidence that this guidance that was shown was also reliable and actionable. Natural resource managers and coastal economic operators often described trust in terms of pattern recognitions as well. So the forecasts also aligned with their mental models of how past cold stunning events have unfolded. And then forecasters, in contrast, tended to cross-validate the information against more familiar institutional tools, particularly with the deterministic air temperature forecasts. For them, trust was reinforced when less familiar probabilistic information aligned with their established guidance deployed through National Weather Service. So together, these findings are showing that while trust increased as the imminent became more imminent, what it meant to trust the information varied substantially across our users and their roles. And then 1 day before the event, really getting close here, our users across all of our user groups were recognizing that the predictive information is signaling an imminent cold stunning threat. So the deterministic machine learning water temperature predictions are now indicating an expected onset and then also the end of a cold stunning event for turtles, followed up by sharp declines in both observed and forecasted air temperatures. And then the air temperature uncertainty information helped to assess the event duration, with many interpreting some of the tight confidence intervals that we see there as suggesting maybe a short-lived cold stunning event. So these signals are pushing perceived likelihood of the occurrence to its highest level across our users and also supporting a bit more concrete response collaborations and preparations. But at the same time, our users are increasingly grappling with balancing both ecological protection and then the economic continuity, which is really highlighting some of the multi-domain complexity of some of the near-term decision-making that's going on within the collaborative and that's being discussed.
Miranda, 1 minute.
Thank you so much. Very close here. So among the natural resource managers and coastal economic operators, trust in the predictive information remained high, grounded again in earlier noted factors. And in contrast, divergence in trust emerged amongst our forecasters. While some maintained confidence based on strong air temperature drops and consistent water temperature trends, others noted discrepancies between recent observations and a disagreement between the National Weather Service and the weather company guidance. So these inconsistencies really led to some forecasters to perceive potential warm biases in the models and adjust their interpretations of the event timing and severity, lowering their trust in both the deterministic and probabilistic information. But most importantly, the forecasters really identified clear pathways for rebuilding trust, such as uncertainty estimations for water temperature predictions, explanations for intermodal discrepancies, and others. So this is showing that as the event became more imminent, trust became more conditional and diagnostic rather than uniformly increasing across domains. So unfortunately, to save time, I'm going to rush through my conclusion slide. So again, here, and just to bring it all together, these findings are really showing that while current cold snake prediction tools are supporting successful preparation, our users' trust and use of this information depend really strongly on their decision context, their workflows, and risk perceptions. So the probabilistic air temperature forecasts that you guys saw a little bit earlier are also helping our users conceptually just conceptualize the best and worst case scenarios, but they also introduced interpretive complexity. Because the uncertainty was tied to air temperature rather than water temperature, which was the variable that actually was driving decisions, users often had to mentally translate uncertainty across variables, which was increasing cognitive effort and sometimes even ambiguity. So these results are pointing toward the need for probabilistic information tied directly to water temperature, as well as hybrid visualizations that allow users to move smoothly between deterministic and probabilistic framing. So more broadly, this work is reinforcing that without ongoing participatory engagement with our stakeholders, even well-designed tools risk missing what users are actually needing. So user-centered, iterative, and convergent approaches are essential for building predictive systems that users trust and apply in practice. I apologize for rushing through those last slides, but I just want to acknowledge all of my funding agencies. Thank you so much, and my collaborators, as well as the TCRC members that participated in our interviews.
Thank you so much, Miranda. That was very interesting presentation. I see there is a comment/question from Carly in the chat. She is saying that she would love to hear about how users engaged with the model one day after the event. So that was actually something that you had to skip for time reasons. So maybe you can just briefly address it.
Yeah, no problem, especially with the predictions now just already showing that the event was already underway. Our users' attention mostly shifted toward anticipating when the event would end now. So some of the updated observations were now showing conditions that were a bit colder than previously predicted, which was supporting some of the earlier forecaster concerns about that potential warm bias in the earlier guidance. So with this, it allowed users to then adjust the event timing for the end of the event about 12 to 36 hours, while also in their heads already adjusting what kinds of changes that they were going to be making with their management strategies as well. So delaying when the economic activity would be resumed, adjusting the timing for searching sea turtles, for sea turtles and fish during that time. But also, I think the really most important thing here is that each of our users within all across these domains, we're also trying to understand, okay, if I make this different type of decision, how is this going to impact this other group? If I say that I need more time to search for sea turtles, was this increase the loss of the amount of money that could be gained from the barging and towing and dredging companies that are pausing their activities to ensure that these vulnerable communities of sea turtles and fish won't be threatened during this time? So I think that's a really cool thing to note. Trust then shifted a bit, but yeah, I appreciate you asking that question.
Thanks. Just a very brief question from my side. I'm wondering to what extent the participants in your study were willing to go along with you to participate in these scenario-based studies. Like, were they willing to like act as if it was a real situation, or how did that work?
Yeah, that's a really interesting question. I think there were some users that were hesitant with the activities because some people felt as though we were testing them, whether or not they were interpreting the predictions as like there was a right and wrong answer. We wanted to make sure that we were easing them into allowing us to understand how they were assessing and trusting and utilizing this information outside of the development framework, which is, of course, our lens. We are the developers and the communicators of this information. But because they utilize this for a very high impact event and something that they've been using for decades, they were very welcoming to interviewing with us and really understood that these interviews were improving and advancing some of the modeling that we are definitely disseminating in a real time. So everybody was very excited. There were some, oh, am I doing this right? Am I doing this wrong? And of course, we had some later conversations on how to interpret these things and how we expected for them to utilize these things at a later time. But they were also invited to give some feedback for the manuscript of this very valuable qualitative data as well.
Great. Thank you so much. There is another question in the chat. Feel free to answer that while you're writing in the chat. But for now, thanks a lot for your presentation, and we move on to New Zealand. Sally Potter is joining us from there, and she will talk about personalization of multi-hazard risk using artificial intelligence. Sally, I see you're already sharing your screen, and it's in presentation mode now. So please go ahead.
Perfect. Thank you. Hi, everyone, and thank you very much for tuning in. And I just want to say a big thank you to the session organisers, but also the conference organisers. Had such a blast this week, hearing all these different fascinating talks. So well done to everybody. My name is Sally Potter. I'm a social science researcher and consultant here in New Zealand, but working internationally. And I'm going to be talking today about how we can get from very generalized warnings down to personalized warnings that integrate multiple hazards using artificial intelligence. Now, warnings are currently aimed at a general audience. So, for example, we've got here the Met Service New Zealand weather warnings that came out in January, and you can see we've got the severe red warning going over a swath of the North Island there, and this event did cause some very serious impacts. The type of wording that goes out in these warnings is very general. It says things like threat to life from dangerous river conditions, significant flooding and slips, and so on. And it kind of is up to the people receiving that to be able to personalize what that hazard and impacts could mean to them. Now, there are some instances of more targeted messages, such as through emergency mobile alerts, or WEAs as they're called in the States, but where you can get these more location-targeted messages to your mobile phone. And you can also have more specific community or sector type alerting, such as if you're in a particular agricultural group or channels that the council or the emergency managers can give more targeted warnings to, but this is reasonably rare. And then, of course, social media, which you can have a little bit more of a lengthy statement so that you can start tailoring that message more to certain communities or sectors or groups. But in general, these are still relatively generic. We know that personalisation of warnings is important to help prompt people to act. So there is research including on how people take warning signs and how they act on that by Weaher. So for example, if you include a person's name in that warning message, they're more likely to respond to it. And some recent research coming out of Switzerland showed that participants from the public want to have tailored heat wave warnings, and it would help motivate them to prepare, but that data privacy remains a concern. So personalisation is linked to factors such as how much you perceive your location to be close to the hazard source. So for example, in a very simple case, for a flood warning, are you on a hill or in a valley? Or are you in a tsunami zone, or are you up on a hill, etc. So that can bring in people's understanding about the hazard quite a lot there too, and their beliefs about the hazard characteristics. So for example, how fast they think this type of hazard could accelerate in its severity and so on. It also there brings in people's experience, either how they've personally been impacted, how their family and friends and neighbours have been, or what have they seen on TV from somewhere else in the country and so on. Also intrusiveness, so how much are they thinking about this hazard and the impacts personally. And there's lots of research on this that can be looked up as well. Now, some of the challenges, and there are a lot of them, moving from these more hazard-based warnings to the impact-based warnings, is that you need to have this exposure and vulnerability data to bring in those different elements of risk. And I've got my paper there from this high impact weather group that we worked together on what those challenges and benefits are of impact-based warnings. The relevant ones here are that there's a widespread belief that the data and the models to support these kind of impact-based warnings are lacking at this point. There are also data privacy concerns, particularly around people's vulnerability information. There are a lot of uncertainties throughout that whole warning value cycle. And there are also concerns about staff capacity. So basically, do people have that knowledge and the skills and the abilities to have all of that data at their fingertips and be able to meaningfully interpret it and apply it to impact-based warnings? And then how do you go that even extra step to physically disseminate these kind of targeted advice? Now, we could use risk models with that lack of data being a big problem. We could use digital footprints through the big tech giant companies. So I've given a TED talk on this, TEDx talk a couple of years ago. If you're interested, you can scan that QR code or look it up on YouTube. But basically, I'm saying the tech giants often have a lot of our digital footprint data already, from our locations to our mental models, our political stances, how tolerant we are on risk, all sorts of things, like the construction of our houses and loads of things. Could they not take all that data and make a risk advice or a targeted and tailored warning for us? Now, this could still be the case, but now I'm thinking, what if we can already do this with AI? What if it's already decentralizing this process? How possible is it for anyone, and I'm going to start with me, to use AI or large language models to help produce personalized daily risk forecasts or potentially warnings right now? Now, my first caveat is I am by no means an AI expert. I'm literally just someone playing around with some AI tools that I've got. So I'm going to show you how I've been exploring this in a personal sense over the last year or so. Now, my framework to support this is really quite similar to a risk assessment type of framework. What I want AI to do is take all the different hazard forecasts and background hazard assessments into account and overlay them. So I'm talking about getting weather forecasts and warnings, getting flood zones, either just general flood susceptibility or, if possible, a flood warning or forecast. I want landslide susceptibility or forecast type of maps. Potentially, you could get wildfire type forecasts, at least get the tsunami zones, if not a tsunami warning. Volcanic activity, either current level of activity or potentially an ashfall forecast, and things like background earthquake models or earthquake forecasts, which will show a higher chance of aftershock shaking in your area following a big earthquake. I then want it to compare my location to what those hazard maps say. I then want it to take into account my vulnerability and capacity information. So things like gender, have I got any dependents? Can I drive? Do I have that kind of option with a transport to get away if I need to? Having a business or not, dependent on these kind of hazards, and the construction of my house. Do I have a vegetable garden? You know, what's important to me and how that will be affected by all the different hazards. And then I want AI to pretty much magically bring this all together and create a personalized risk level and tailored guidance advice for me, so that it gives me my overall risk level for the day, or perhaps prompted when a warning gets to the risk level gets to a certain threshold. So here are my attempts to do this. So the first way I try doing it is, anyone can do this, open up an AI large language model like ChatGPT or Perplexity or so on, and just put into it, what's my risk today? So I've got an example here, and it's about somebody who lives in a little town called Taihape in New Zealand. It's a really rural town. And I just said for vulnerability and demographic type information, I'm female, I have children, and I live on a hill. And it spits out a pretty good description of what your hazards are today for multiple hazards. And then it gives targeted, tailored advice on what I can do to mitigate my risk. Now, the complication is there was no warning this day for weather, but the Perplexity model said that there was. So, giant red flag there. So in terms of trustworthiness, it is okay, but it uses old data. There was a red weather warning in this area the day before, and so it was pulling in that information. Also, I figured out it can't really read maps yet, spatial kind of data. Giant flaw when it comes to hazards and exposure. So we might be able to fix this if we can connect this data and have better prompts to things like APIs from trusted weather sources and so on. In terms of intrusiveness, this is not so good. We need to go into the website whenever we want the information and ask it. But it could be quite good in terms of, oh, I've seen a warning coming from an official warning source. Give me some more tailored advice around this, so you could still go in and do that. And in terms of personalisability, which I'm not sure is an official word, but there we are, it was pretty good. You can add the context to get it to produce this more tailored context for you. The second method that I used was what we call vibe coding. So this is using the large language models to help with Python coding. I have zero experience in coding, so this has helped me a lot. And I got it to calculate my risk and email me the output every day. Now this was actually pretty good. All it took at this stage was the rainfall forecast and the wind gust forecast from Met Service, and actually from Open Meteo, and then it combined that with the New Zealand GeoNet official volcanic information about what the current status of volcanic activity is. I have a volcano about 50 kilometres away from me, and it was at alert level 3, which means minor eruption in progress. So potentially, if the wind direction was right, I could get ash or gas at my house. So it brought that in and combined it and gave me that overall hazard risk there in this example of yellow. So this was really good, but it really does need that robust data link going back to the APIs, the official data sources. And I could bring in the common alerting protocol, I think, a little more to make sure it brings in when Met Service has official warnings out. This was good in terms of intrusiveness, email me daily, but doesn't update more than once a day. So if a warning gets put out after the timing I've set this to, it misses that warning, which is not so good for things like thunderstorm alerts. And personalisability is pretty good, but I had to define what I want it to say. So if the alert level for the volcano is at 3, I needed it to give me, I had to write the specific prompts, which is not great for most people who don't know how to do that kind of thing. And then the third methodology that I've tried here is using the same kind of vibe coding with the large language models to actually produce a website that you can put your address in or the location that you're interested in, checks the risk, combines different hazards, and comes out with your risk score for that day. Now, this was pretty cool because it moved it from being a personalized tool for me to theoretically anybody could use this. And again, it uses that Open Meteo weather information and the GeoNet feed. So in terms of trustworthiness, pretty good. Intrusiveness, not great. You still have to go onto that website to do it. And personalisability is okay. I haven't yet figured out or moved on the process to get any kind of vulnerability and guidance information into that, because this is all just for my own interest at this point, not really any kind of funded official research project, but it's got that potential there. So the implications of having these sort of tools available to anybody right now is that sectors such as agriculture, horticulture, they could just use this kind of AI-powered information and tools rather than paying weather services for that tailored information, which is often a commercial way for weather services to keep afloat. So I think this has quite huge implications for many weather services around the world. Instead of weather services potentially moving towards impact-based warnings, maybe people can just use their own interpretation or their own prompts on their own personalized context to get that impact information relevant to them. So again, this has big implications potentially for weather services. But this relies on a really heavy reliance on these open access weather forecast information through the APIs like OpenMeteo has, but that New Zealand-based models do not have because they're quite restricted. So this really is the crux of it, is what weather information can we trust out there in the wide world that could be drawn on by these AI models. And then, of course, we need to have these public-facing warnings still, and so how are they going to be run in parallel with these AI type of risk information? Who's got the accountability for these AI type models? Because the AI generators certainly won't have. We have to personally be accountable for that. But how are they going to be different or working with each other? So the questions this really leads to is, if I get a warning or risk-based information using AI and it's different to my direct neighbor who theoretically could be getting the same hazard type severity as me, but their vulnerability might be different, how does that change the way that we trust our warnings and our information? And how can we avoid over-reliance on AI in future? So this is really kind of the extreme case. But if we all were just relying on the AI and these tools to get our risk information, what happens in an actual disaster when the power goes out and we can't get those anymore? We've still got to keep all the official sources and channels and robustness going for these sort of cases. And then how can we reduce biases and inequalities instead of exacerbating them using AI? And that's it from me. Thank you very much for your attention, and I look forward to our discussions going forward.
Thanks a lot, Sally, for a very intriguing presentation. And yeah, you already put up quite some interesting and relevant questions in your pre-final slide. I'd be really interested to see if that is also going to feed into the discussion we're going to have after the break. Thanks a lot for that. I see there's quite a lot of questions and comments as well in the chat. For the sake of time, I would suggest also, because we're going to discuss this topic after the break as well, we can both ask you to respond in the chat, as well as like maybe bring some of the things that you think could be relevant in the discussion for our more like broader panel discussion that we're going to have after the break. So for now, what we do, I want to thank you again, Sally, and also all the presenters for during this this block of presentations for some very interesting and relevant talks. Thanks for the discussion also throughout the session. We are having a break. During the break, we are inviting you, and you will see already now that Julie is sharing her screen, that we want to prepare for a broader panel discussion, just opening up the floor both to inviting all the presenters that presented earlier during the session, as well as the audience, to go to Slido. And if you can use the QR code as well as the link that I'm just now pasting in the chat to go to Slido and ask and write your questions in general about this theme and about AI, about the specific presentations and questions that came along there, which will be well, basically a basis for further discussions after the break. So what we will do, you can upvote all the questions that are being written in the Slido. You can already start doing that during the break, but also throughout the session, it's possible to do that continuously. We will spend the first half of the next part of the session with a discussion among the speakers with some dedicated questions. And then the second half, we will open up the floor for other questions coming from the audience. So it will be really a even more interactive part of the session, really bringing together all the topics and themes that we are able to discuss here. So please go to Slido while you're having your break as well and stretch your legs. We're looking forward to continue after the break. I suggest we take 10 minutes, even though we're a little bit late, and we rejoin at 1:15.
All right, everyone, I'm going to bring us back together. And I'm seeing some videos turning on. Thank you, Chris. Thank you, Thomas. We've had such a great set of talks, so much food for thought. I feel like we need another whole day together just to talk through all of this. But if nothing else, we have 45 minutes. With most of our speakers from today, we've only lost a couple of them. So we are going to have Chris, we're going to have Okunlawan, we're going to have, so Stefan and Miranda are not able to join us. We'll have Aaron, we'll have Carly, we'll have Thomas, and we'll have Sally. So hopefully I have everyone there. And we are going to shrink this to 45 minutes just so that we make sure that we can actually wrap up in time, have a few minutes for Carla and for Chris Davis to kind of bring the whole Weather and Society conference together. So this is how we'll do this. We are going to have first a discussion among our speakers. And what I had asked them to do is to spend no more than 2 minutes just reflecting on some key perspective or idea or question or anything that they want to share and bring up from any or all of the talks. It can be something in particular. It can be kind of cutting across them. And then Jelmer and I came up with a couple of questions, but then we also kind of ahead of time asked all of our speakers if there was something in particular that they wanted to raise. And as Jelmer already alluded to, the question Ava posed earlier is the same thing as what Chris had raised. So we have some of these questions for discussion. But importantly, we will use the last 20 to 25 minutes for questions from all of you. So please go to the Slido. You can type in a question and then you can upvote it. And frankly, the egalitarian in me doesn't like the idea that we have to democratize this, like make it so that whoever gets the most votes like wins in that way. But we're going to use it for this purpose. We have so many great questions, and hopefully we can actually capture them, including the ones in the chat. And honestly, Jelmer and I have talked about maybe having a follow-on conversation, a webinar or something along those lines, also potentially supported by WMO. And I think all the great content so far really suggests that that will be absolutely wonderful and necessary. So with that, I said I was going to go in the order of the people who presented. So Chris, I'm going to hand the mic to you to give some key reflections.
All right. So first off, it's just great to see the breadth. And I think that is both a strength and I think one of the biggest challenges, right? There's so many ways we could approach these topics, and there's so many ways that we can dive deep, right? To go really into our context and go really into what we care about. The idea is that how, when we're all going so deep, do we also go broad, right? And so how do we think about that issue of scale? When we do make advances in our own domain, how do we kind of leave better trails for other folks who want to do the same thing, or to give the right insights? So, hey, I know something that might be a piece of the puzzle you're trying to do in ways that move forward, right? So when you make a technical advancement or you understand the social system a little bit better, how can that contribute towards the other projects, even though they do tend to be more specific because that's where you make ground? So I don't think I have like a real clear answer to those things with my like 45 seconds left, but I want to highlight the idea of how can we be these advocates in our own interdisciplinary spaces, but also kind of make consistent progress in an interdisciplinary space, right? Because I think we get taxed with, and folks like this working within a new domain, but also having to bring in some AI, bring in some neurology, bring in some social science. So you're already doing a lot, much less than to synthesize those different intersections across other people's intersections. So kind of challenging us to think about what does interdisciplinary theory building look like in foundation laying. That's the thing that comes to mind across all these talks for me.
Fantastic. Thank you, Chris. All right, I can't see everyone here, but Okunlawan, I hope you're on. Don't see your camera. Let me look. Looks like you're still here. I think one thing we could do is give him an opportunity. I can message him to come back. But then that would mean, Aaron, you are up. Are you ready?
Hello.
There you are. Fantastic.
So there was a lot of really interesting talks today, particularly at the intersection of social science and using these products operationally. It's something I wish I had gotten the opportunity to do more. And it's something that I think is very important, particularly, Chris Wers brought this up earlier. There just seems to be an explosion of products on the market right now. I feel like every time I open LinkedIn, there's a new company, a new app, a new add-on that you can use. And it makes me wonder kind of what the next 10 years looks like with respect to acquisition of using these products, and what will and won't hold out. So in one way, it's really exciting just because there's kind of a plethora of options right now, but kind of like when you go to the Cheesecake Factory and you're given a menu that's the size of a novel, you can get paralyzed or fall back onto your own options, or what you're familiar with. So as someone who's not a social scientist, that's something I'm really interested in understanding and keeping an eye out for in the interim. And yeah, I think trustworthiness is incredibly important. I think there's a little bit of a lag just because these products are so new. It reminds me of the early days of NWP when numerical weather prediction models, when we were having to do really funky things to get NWP models to work, like remove seventh order terms at the edge of boundaries or reduce energy propagation to below the speed of sound. And I imagine there will be a lot of interesting takeaways like that in the near future as well. And how does that intersect with trustworthiness? I don't know. Anyways, here's my cat. That's it for me.
Wonderful. Thank you, Aaron. And if anybody's tracking me, I'm not doing my math because if we do have Okunlawan joining us, we have 6 people here on our panel. And we're just going to trust my memory that I've got these all in the correct order. So Carly, you would be up next.
Yeah, sure. So I really enjoyed all these talks. I thought it was really cool to see the use of machine learning or AI in all of these different contexts. I feel like they were all, for the most part, like really different flavors of applications to weather. So that was really interesting. And one sort of takeaway I had, I feel like across many of the talks was using AI as a decision support tool. So like emphasis on the word tool, not for automation or taking over a replacement. And I think this was kind of like a big thing that was mentioned across numerous talks. But yeah, I'm really excited to chat about these talks and our questions some more.
Thank you, Carly. Thomas.
Yeah, thank you. I really enjoyed all the talks today, and I can only second those points that were brought up earlier. Maybe I will just add a very small thing. I think what really became obvious that is like integrating different parts of science, social science, and partners into our work, like really working interdisciplinary, but also really working transdisciplinary. That leads to real progress. And I think that's something, and it needs to be done good and properly, and it has to be well documented and reported, and then other people can read it and can learn from that. And I think that's something that's nice to see, and I think that's a lot we can pick up.
So I think also this connects nicely back to Chris's comment too, Thomas, that a lot of it is about the content, what we're learning, but also the methodologies, so that we're kind of leaving those trails for other people to build off of versus having to forge anew. That's really great. I'm going to take this moment really quickly and ask a question for Carly, because in the spirit of what Thomas just said with integrating social science, physical science, and partners, Carly, you were talking about the interface that you developed. And I honestly, in my own past experience, I did this in one of my projects, and I used to get so frustrated that people would tack on social science at the end, and I realized I was tacking on the developers of the web-based interface at the end because I didn't fully appreciate the complexity of what all that would entail. Did you incorporate that and consider kind of that expertise in your project as well?
Yeah, that's a great question. Yeah, so sort of, yeah. So in our model development process, we definitely had some visualizations included, but they were by no means like a tool or a dashboard. So we kind of had some early visualizations so that they could help, make sense of what the model that we're doing. But then I did kind of set aside like a few months to develop the tool, but even that was sort of like bare bones. So like when we did the set of interviews, I always started it with, this is a work in progress, like this is not a final dashboard, but like as like developers or anyone really knows, it's really hard to show unfinished work, but like doing those things like side by side, I feel like was really important because you don't want to show a final product that you've worked on and they don't like it, or like you're saying, Julie, you don't want to just have to build the dashboard at the very end tacking it on. So it's really, important to kind of do it side by side, but tricky too. Yeah.
And just so important to recognize there's expertise there too that we can pull into these kinds of efforts, right? So yeah, thank you, Carly. Sally, you have some reflections for us.
Sure. So I thought with the different talks that we had today, they really were starting to wrap around that warning value cycle. So we had some talks that were talking about the how to integrate machine learning with modeling, whether that's about the hazards or starting to integrate the impact information. And that feeds really into that underpinning risk knowledge on a long-term basis, as well as more kind of better forecasts and warnings. Then we've got that monitoring of the real-time conditions, with the snow on the road and so on. So to try and mitigate these really short-term timeframes and mitigate those further impacts. And then we've got round to the communication and personalisation. And ideally, we'd be getting more into that response, evacuation side of things as well. So can we come at this whole thing in a bit more of a structured way? Where are the biggest gains in improving warnings using AI? And how can we make sure that we are tackling all these different aspects when it is such a new thing at this stage? So that's kind of what came to mind when I was listening to all the talks today.
Thank you, Sally. As you were listing I was writing it all out, I was like, that's a big kind of problem space, right? When we're talking about all those different components and, the spatial and temporal aspects. And so it is a lot. And so I do think this question of how do we think about doing it in a structured way? How do we bring in AI is great. And I wonder how we would answer that question, right? Because it's so complex and I feel like there's so much work to be done, but I love that we're coming together to ask these questions and answer them as part of a community so that we can be thinking about it. Okunlawan, are you with us? And if so, do you have any comments? It's getting late there. And while we're waiting there, it's getting late for a lot of people, including Jelmer. Jelmer, do you have anything that you want to chime in? And if not, I don't want to put you on the spot, but want to, of course, invite you to weigh in here too.
No, I think this is really great and great discussions. And one of the things that came to mind for me, also related to personalization, is like the agency that people get to basically set their own levels and actually, kind of like outsource towards like even more to the end user what we want to communicate, maybe even. So I really wonder, okay, what kind of dynamics go there? It's going a little bit into the direction of, okay, where does the authority lie? But also then more in terms of what kind of agency do end users themselves have in terms of what information they want to basically act upon. So it's this interaction, I think can really be a game changer, and I really wonder what direction it's going to go.
Wonderful. Okay, thank you, Jelmer. Okay, so we have a few questions here, and I do want to kind of balance out how much time we have just answering the questions we came up with among ourselves with the audience. So if you will all kind of indulge me, I think I'm actually going to jump to the second question because I'd like to spend maybe only 10, 12 more minutes kind of in this phase before we open it up. We can always go back. And this is going to be kind of open for all of the speakers. So please raise your hand and I will call on you accordingly. I'm jumping to the second question. Carly talked a lot about co-development, and it's important for building, and I assume you can see this, yes, you can, trusted and useful products, but it can be messy in practice. I think maybe even one of the comments talked about this too. What's the biggest hurdle in moving from a successful research project to a tool that actually lives in a user's daily workflow? What are unique aspects of co-productive messiness to consider in the context of AI and machine learning? Not a small question. Sally. And Sally, we trust you're there. I can see your beautiful background, but not your lovely face. I don't know if that's true for anyone else.
I don't know why my camera is doing that. Shows how good I am at IT, which is slightly concerning in this forum. I think that one of the biggest hurdles is the different timescales and the pace of development, right? How social science research can take so long, or any kind of research and model development can. And yet by the time you finish your research project, the entire AI, situation could have changed. So I think that's a really, really big hurdle for us. But also, in terms of people's capabilities and familiarity and training, we're going to have a huge spectrum of how versed people are in using AI and what it can and cannot do and how best to use it. In terms of our users, like if you think about emergency managers or sectors. So how can you try and produce a tool or supporting guidance type information for such a range of experiences as well. So I think those are a couple of hurdles there that we need to consider.
Thanks, Sally. Chris, I think you were next. I know the hands might jump around, so I'm going to trust you all are going to keep me honest and yourselves honest as I'm taking notes and looking down. But Chris, I believe you were next.
Yeah, I think building off of Sally's comment here, also being able to kind of align your expectations and your sort of incentive structures across these different groups is going to be key to success, right? So what do you need to be participating as an academic researcher, as, an operational person? And so like, what is, the ideal outcome for you, and what is like the ideal time frame, and how can we reconcile those as much as possible up front so you don't hit tensions later on? Right? Because if someone needs to work, at a long scale operational process before something can be actually used, and a developer needs to have 14 new models, and a social scientist needs a year, so how do we make sure those work in some ways that are, more aligned with the process? And the paper that Carly's working on finishing up now talks about that. Like, how do you kind of balance some of these tensions, and what's kind of good strategies just to get maybe a little bit of each of the pieces instead of trying to do all of them full force? I think those are key too.
Thanks, Chris. I think the other thing I'll add to that, which I think is embedded, is what are the incentive structures of the users and devoting their time, right, to all of this too, and being kind of mindful of that and bringing that into the conversation and consideration. Thomas, were you next? I think so. That's what you're coming up.
I don't know, but Miranda, maybe you want to.
Yeah, sorry about that, Julie. I did say at first I was gonna be leaving from here, so I understand. But yeah, just to tag in just really quickly, yeah, there are a lot of groups that help with the operational development and deployment of some of these models. And so it's not just, the developers and understanding how robust these models are, and depending on, if they're great at good accuracy for extreme events, or if they're giving great calibration of uncertainty, but it also goes along with the risk communication scientists, if they're involved, and how they're communicating this space between the developer and the user side. But also we tend to forget the operational team that helps go from the model within a research space to the operational space. And understanding the limitations and the goals of each of these groups are definitely complex, and something that some of you guys have already highlighted. So understanding not only the incentives and the goals for each of these groups, but also the limitations, and understanding how timelines can be shifted when also trying to deploy them for the users. It's a very complex space, so I'm glad that the question was asked.
And I'm sorry, Miranda, I didn't do my due diligence to see who all was joining us. I was just basing it off of your email from before, so I didn't even give you a chance to provide some reflections. So don't hesitate to put something in the chat if you would like to do that. Thomas, and then Carly, and then we'll go to, I think, another question.
So yeah, I just want to pick up what Sally said with the time scale, but maybe from a different perspective. So what I think it's quite a challenge is that most of the situations we're dealing with, like crisis situation, they call for quite rapid activities, and that might be like someone said, I don't know, who was it, Aaron, who said like looking into every time there's a new product, there's a new tool, whatever. So the development is quite quick, but regulation lags behind, and also in a case of a crisis event, we have seen that during COVID that there's a lot of things going on, and then afterwards, yeah, then we have to make sure that issues of privacy, issue of fairness, others are like well implemented, and that's a thing that might be like in the development, that's something we might think of at an earlier stage. But yeah, as I said, like in times of a crisis event, that's actually quite a big issue, because then things will just come up and will be there and will be on the market, and yeah, as I said, regulation lags behind in this case.
Such an excellent point. And so then it really falls on the developers and all of us who are doing this to be kind of out in front of the regulations, right? And hopefully then guiding what those should be, but not waiting for them to guide what we're doing. Excellent point, Thomas. Carly, you want the final word on this?
Yeah, sure. I was just going to say, I think one big hurdle or sort of piece of the messiness here that I've experienced is just working with end users. They kind of live in a whole different world than we do. You know, they live in a different field, and so not having a common language necessarily. So when users mention, you know, I want confidence, well, what does confidence really mean? And oftentimes that takes like a whole discussion to get to the bottom of what that would mean from a development side of things. So really just like understanding the context or nuance and really working with them and having those conversations is super important.
And I think embedded in that, Carly, and what so many people have talked about is that you don't get to just parachute in and have like the solution for them. It takes time to build those relationships from the outset, right? And a lot of listening before you're even thinking about what to develop, and learning each other's language. So I think because we were talking about timescales, and I'm kind of mindful of time, so time is really on our minds. I'm going to jump to this question that Chris had raised and that Ava kind of also put in the chat. So AI and machine learning capabilities develop quickly while systematic research takes time. We're talking about some of this, but I just want to give a little bit more space. How do we effectively reconcile the speed and scalability of our technical AI and machine learning capabilities with our understanding of how these systems affect decision making, which is often much slower to develop and highly context dependent? We've touched on this a lot, but I want to give just a little bit more time in case there's anything else regarding this kind of misaligned timescale topic that we're talking about. Sally. And Sally, we have you back with another beautiful background too.
So I lost all the chat though, so I'm sorry to anyone who I didn't get to reply to the question. It's now gone from me, but yes, so this is obviously a really big challenge. And we need to somehow, when we start, let's say, a 3 or 5 year research program, we have to have an idea of what the world is going to be like at the end of that so we can apply our findings. But of course, that's like nearly impossible, I'd say, when it comes to AI because of the pace of development. So I think we need to try and take what our understanding already is, and this was touched on in one of the presentations in the Q&A already, I think, but take what we already know about the world and our social science lens on warnings and apply it as best as we can, and you know, at the same time as trying to conduct research. And that research perhaps needs to be at quite a high level to make sure that we can still apply those findings at the end of it. So, you know, potentially it could be on things like trust and consistency and so on, because hopefully that would be applicable no matter what the AI world is looking like at the end of it. But yeah, I mean, that's kind of what we do already when we apply our research into practice is, you know, rather than saying, a physical scientist might ask me a question about how to communicate a forecast for landslides or for eruptions or whatever. And instead of going, okay, cool, I'll get back to you in 3 years, you know, once I've looked into this. You can't do that. You have to just go, well, based on what I know, here's what you should do. And it feels a bit like winging it quite a lot of the time, but you're bringing in all that knowledge of the literature at that point to make the best, you know, result that you can right then. That's kind of the best we can do at some points.
Thank you, Sally. Chris?
Yeah, and I think that this is not one we're going to solve today, and I feel like I have to take a hit at it just because I brought it up. But where my mind goes is how can we start to do social science in these spaces when we're the deep divers at more of a middle level, right? Like we tend to be the people who are in really context-rich spaces, and how do you challenge yourself to take a step back? And maybe that means doing more cross-sector research, right? So trying to pull some sort of framework together that pulls together like with the DOT folks, the folks from Miranda study, from coastal marine systems, from forecasters, like, are there any commonalities? Like, what are we seeing as the big foundational points, and make more of these sort of cross-cutting papers that could be like more generally applied. So the takeaways are, tested and more robust at these higher kind of levels. They may not be as detailed about what's going to be, actionable or useful, but they start to give some folks, as we go into more and more domains with AI decision making, a clearer sense of where to start, and maybe where some of those like theoretical frameworks can be developed.
Carly.
Yeah, this kind of follows nicely what Chris was saying, but just kind of to be able to provide like a achievable or practical framework for folks, because I know a lot of people who might not have experience working with end users, it can feel a little daunting, but doing something is better than doing nothing. And so kind of setting, like working with the time constraints and the competing priorities that you do have is still better than not doing it at all if it feels too daunting. So something that really worked well for us was like working with academic off weeks, that way we can avoid sort of the time constraints of the normal academic year, and working with shorter interview time blocks. But, like Chris was saying, just developing these themes that exist that can help people starting from scratch would be really helpful.
We really need support, like research support, to do this kind of integrative synthesis type of work, it seems like. Miranda.
Yeah, just to concisely go off of what Carly and Chris were talking about, while regulation may lag, especially with technological change, the community still can establish some of these best practices, even document failures, raise awareness of some of the risks that are involved when going through these types of studies and communicating and discussing with these types of groups, while also articulating principled limits. Something that Carly was pointing out was do it because you should, not because you can. I think that will allow us to get to the steps that we need to, especially when trying to understand how to develop trustworthy AI for such a broad base of users.
It's wonderful, Miranda. Thank you. I think, Thomas, you can have the final word on this. Go for it.
Okay, sorry. Now I just want to pick up the question of Chris here in the chat, and also what we just discussed is, I was thinking about it. I think it was Chris who said it in his introductional talk in the keynote, that everything is context dependent. So and that means that we always have to look again and again into what seems from the outside the same topic, but which isn't. It is a different thing in a different context, and this takes time. And this is why we do research in the US and do research in Europe and in Africa and Asia and then in New York State and in New York City and whatever, and it is a different context. And then you go on household level or whatever. And so that's a lot to do, and then picking up what we said earlier, that means there's a necessity to have a good framework and a methodology and proper reporting and stuff like that.
That's so fantastic. I think just to pull all these threads together, it is context dependent. There's a perceptual piece to this, but what you're saying too, Thomas and Jelmer and Chris and Carly and Miranda and everyone, that if we can be really intentional about the studies we're doing, then we can think more about what does and doesn't generalize, right? Where we need to do things specifically. And that does require all of us, I think, as a community working together. I think the other piece I'd like to pull into this, because I think it's important, we have colleagues who are sort of the deep AI experts. That's their deep background in a lot of the convergent work that we do. And one of them I'm thinking of in particular is the one who will say kind of caution people against the gold rush of certain types of AI, right? And so kind of having their sound, deep expertise, because they know what is and isn't doable and how to think about bringing those technologies and techniques into the space in a really meaningful way, but also where to put kind of like those guardrails up, I think is really key. So ensuring they're all part of these conversations as well. So this conversation's so great, we're going to need a couple more hours. So folks are going to have to stay up. I'm going to jump over here and see what is floating to the top from our audience. So To what extent can machine learning reduce the computational and energy barriers for forecasts in regions that are lacking traditional numerical weather prediction infrastructure? Who wants to take that one? Thomas.
I know I have an answer, but I just wanted to highlight that that was actually a point that was also brought up in our survey, which is it is a very important topic, but I'm not sure. I mean, maybe Aaron, you have an answer on that, but I'm not sure if this round of people knows about to answer it. Yeah, I'm not sure, but it's quite interesting because it is a topic which is very prominent.
Yeah, Aaron, this question looks familiar. I bet you have an answer to it.
Yes. I asked it, so I'll take a crack at it. I think it can do a lot by way of giving operational NWP models to areas of the world that don't traditionally have them or have observation networks. You know, predominantly we have East Asia, North America, and Europe. And then after that, it's really sparse. And, you know, we have entire oceans where we have buoys that are responsible for parametrizing these models. I think kind of what some of the what makes things like GraphCast advantageous is how cheaply you can run it. And I do think that there is a lot of utility in using these models in sparse observation locations. I also think that it should be done, you know, with trustworthiness and with integrity. So I feel like you would have to build in perhaps user feedback frameworks so you can, you know, just like we do with our own weather apps here in the States, where you can say, it's actually not raining right now, even though you're predicting that it's raining. Things like that, I envision would be part of it. But I think kind of what's exciting right now about machine learning is this democratization of NWP models, and that you can just pool the parameters for really powerful models off of these websites and then tailor them to your own specific use case in your own backyard. And yeah, I don't think we'll answer this question here either, but I think it'll be something that evolves in the coming years.
I wonder if there's any questions we're going to answer here fully. Probably not. These are big, vexing, complex questions, which is part of the reason that Jelmer and I designed this to be transdisciplinary convergent by nature. Is because these are they really require the expertise and the integrative thinking of people from really different backgrounds and sectors and job roles. I'm kind of keeping my eye on the clock. I'm going to pick up one more question here, and then I really want to go back to the question around personalization and trustworthiness, and personalization and localization of warnings, because that had so much in the way of conversation that got spun up in the chat, and I would like to make sure we have a few minutes to come back to that. So what must be done to ensure that AI and machine learning level the global playing field regarding accessibility and usefulness of warnings? And I think this is a nice segue into the other question around personalization and localization. So does anyone want to take this to start?
So I've been thinking about this in a different context. I think about rural and urban communities, where we talk a lot about there's a digital divide, and this is true across global scales as well. We're even thinking about like broadband access. Like if you don't have stable internet access where you're at, you're not going to be able to use these tools. If you do not have like, you know, the computational resources, even the baseline ones for like smaller models, you won't be able to use these tools. If you don't have the knowledge in consistent places, you won't be able to use these tools. So there's a lot of concern that what is currently like a digital divide in some places, whether that be rural to urban or, you know, like global south to global north, is going to become like the digital chasm, right? So not only do you not have access to these tools, the tools are getting more powerful. And then we shift some of the dynamics where then the market goes to those who do have access to the tools. So not only you're not going to have, you know, the cutting edge tool, they're not going to stop making tools for the like the lagging edge of it, right? So we really potential big imbalances. And so how do we deal with that is like making sure people have not just access to AI tools, but the underlying digital access, right? So let's not worry about getting people, you know, the latest version of XYZ model. Let's make sure they have stable infrastructure so they can handle the next model or the models after it, right? Like instead of like, do you have access to this one large global model? It's like, do you have stable broadband access? Do you have like computational resources that will last, you know, 5-10 years? And so that we can start to build more of that broader structural resilience as opposed to like reacting to each model, right? And so kind of having more of a scaled approach where we like maybe one step backwards to why we had the divide in the first place, as opposed to trying to get people right there. And the second part, I think, is being really careful about the role the private sector can play in some of these spaces, because it also could potentially create a pretty big opportunity gap where people could become dependent on, you know, products that are private sectorally funded, which then could be, you know, leading to price gouging and like taking over a market. And so like, you know, we want to make sure there's some public investment and broader international investment in these baseline structures, so there is more autonomy to pick different tools and not be reliant on other systems. Those are my thoughts. But yeah, we'll not solve that one.
Yeah. I'm eager to find the one that we're going to be like, yeah, we solved it. That's how we're going to end. Thomas. Let me jump here.
So yeah, like I just wanted to add that I think it's not only about the access, but also about question of equality and especially regarding what kind of data is used to train the model, and then again picking up Chris aspects of like urban versus rural, global north, global south, whatever. So I think that's quite important to have like a really like a fair and an equal accessible systems.
And I think this segues really nicely, Thomas, if you will give me permission to touch on what Sally raised in terms of issues of data privacy and data scarcity too, when we're also thinking about, and sort of like equity and those types of things, when we're thinking about kind of the personalization. And let me see if I can find this. Here we go, just to make this, hopefully that's gonna to display for everyone. So going back to thinking about personalization of warnings, and I realize that I'm the one who keeps pulling in this word localization. It's not on the slide. I don't know, Sally, even that you necessarily use that, but I tend to think about those things because they often get discussed hand in hand. So please kind of disentangle this if you think I'm, you know, overly kind of coupling these ideas. But thinking about personalization of warnings, what kinds of social data are needed to develop personalized forecasts and warnings robustly? What related questions to consider about sharing such data and so forth. And or I think we can open this more generally to the conversation around personalization of warnings because it generated so much conversation in the chat. So maybe we will end with this. I'm going to like seed this for Jelmer really quickly to say if there's anything, Jelmer, that I'm missing that you want to weigh in on, since we have like 7 minutes before we hand it over to Carla. Have that in your mind and please feel free to chime in. So who wants to take on this question? I think Sally went up first and then Miranda. So I do have to keep my eyes because the Zoom doesn't order people properly. So Sally.
Okay, I can give it a go. So the aspects of sharing of data, for me, logically, we can frame this as a risk kind of equation, right? Where we've got the hazard and then we've got the exposure and the vulnerability. So it's in reality a bit messier than this, but if we can bring in things like your location and then aspects from your mobility issues, if you've got dependents, what resources do you have, and what does that person value in their context, whether it's animals, stock to look after, you know, gardens, horticulture, or your local business and so on. Like, there's a huge, huge list of things that could feed into these type of models to give you really personalized warnings. But this can be done in different ways. I think you can either have that kind of tech giant approach where they already have this data and they can just pull on it and it's just all done for you and it comes to your phone, you know, and like we get weather forecasts already from some generic model. We don't know where it's coming from, but it comes. Or we could have official agencies that ask for that type of data. You know, when you sign up for the app or whatever, you could say, they could say, what is your gender? You know, what sort of dependents do you have? And all this kind of thing. And that's where people start cringing away from sharing all this personal data with the government potentially. And then you could frame that in a slightly less intrusive way so that it's more things like, would you want to get warnings, you know, for people with a lack of mobility? So you're not necessarily saying, I have a lack of mobility. It's more like, do you want to get one? So you can start pulling away from how much of this personal data you're actually sharing and just reframing it in a different way. Or you could have these large language models where you personally just chuck all your data in there and you don't mind, and you say, you know, here's all my things. What have you got for me? Now, the danger with that is that data can then be taken and used in other ways that you are not aware of, and potentially some of this information can get identified back to you, I've been told. So if you put in something about perhaps your health or medical history, that could then come back in other ways. You could also have that kind of information, like say there were some characteristics that might get labeled as you being a vulnerable person, then that can be kind of remembered and used in other ways, and that label can stick with you in different contexts, which can then turn into more biases against minorities, and get kind of set in stone over time, even though it was perhaps context dependent. We've had that in the chat, but this data could get used in insurance kind of models. And so then your personal premiums could go up, and or you could get declined cover, which greatly affects your risk. And also your location in particular could get fed into things like surveillance, which can go well beyond that particular event. And as they monitor your compliance, or can bring board into other kind of institutionalized applications. So those are some of those negative consequences of oversharing your data that we'd want to consider in a warnings context.
Thanks, Sally. So you can tell I'm not a typical Zoom user. I think I just figured out maybe it orders by alphabetical by first name. But if the Zoom developers are listening, do the Google thing where you actually number people, and that, of course, should freak us all out. But Miranda, I know you were next, and then we'll go to Chris.
Yeah, no, I appreciate that, Julie. Yeah, I'll admit I do have some hesitation around just the full-scale AI-driven personalization of warnings. You know, some of the things that Sally mentioned, of course, but in high impact, high stress events, I think human expertise and domain knowledge are still playing and should still play a really critical role. But that said, you know, personalization isn't really going away, and AI isn't either. So the question, I think, it becomes, would it actually require to do this responsibly? So I think robust personalization would require more than just some of this demographic data and localized data. I think we need information about how different groups of people are perceiving different types of risks, how they've responded to past warnings, what communication formats they find the most actionable, how timing affects their decisions, even in what constraints, and Sally also talked about that, but also financial, logistical, cultural, it all shapes their ability to act, really. So that sounds really complex and really deeply contextual data that we may or may not have. So some of this information exists through surveys, communication, community engagement, and behavioral research, but it's not systematically collected or structured in ways that easily plug into some of these systems, these AI and machine learning systems. So even if it were, again, Sally was pointing out some of these really big, you know, issues and concerns like privacy and data ownership and consent, representativeness, and even pointing to the point of the risk of reinforcing identities and inequities of certain groups that are underrepresented or even mischaracterized, which is the scariest part, right? So I think this challenge isn't really just technical, it's really ethical and governance based, something that we were talking about earlier. So if we do perceive and pursue some of these personalized warnings, I just think that we should be prioritizing transparent data practices, some more meaningful community engagement, and then safeguards to ensure that personalization enhances equity rather than undermine it. So not giving a solution, but, you know, sorry about that. That's just my thoughts on this particular
They're
topic.
fantastic thoughts. And before I hand it to Chris, I'll say, and there are certainly social scientists who study a lot of how populations have been marginalized in just countless ways, in like historically, and to also bring their expertise into these conversations would be fantastic. So Chris, you will probably be the bookender. You started us off and you're going to end us off before I hand it to Jelmer, and then who will hand it to Carla. So go for it.
I regret raising my hand because Miranda had some great points, and much strongly or stronger articulated than I was going to do. I feel pretty similar to Miranda on this, and I think the question I pose is, if we aren't sure the implications and how these data will be used, and if we can guarantee governance, should we be collecting them and storing them? Right? So if you can't ensure that these are going to be used well and effectively, is it ethical to have them be collected? Because the idea is, it's not quite right in the first one. This version 1.0 could ruin it forever, right? So the idea of we have these things, they end up in the private sector hands, and they go and kind of lead to these negative outcomes, or people, take XYZ behavior because they trusted them, and then it doesn't come through, and we don't know exactly how the responses are, and we kind of overcommitted them. We could damage that institutional trust and kind of the whole opportunity for these sorts of tools when we do have the capability and we do have kind of some of these things figured out. So kind of this instead of the more market-based approach, can we flip this to be more of a precautionary principle? And until we can demonstrate with sufficient evidence that they're kind of robust and safe, not do it, right? And then think about, what is that bar for safety that we need to have, and how do we roll these out in contained ways or with select groups first to monitor as it works, as a kind of exploratory tool than a thing we do. I think a lot of caution here is really, really needed for all those reasons that Miranda outlined.
What a fantastic past 3.5 hours. Oh my goodness, my brain is full. I feel like we have so much, we have lifetimes of work to do here. And I'm also so inspired always by, I think, kind of the clear commitment that we all have to doing this type of work well, to better serving society, to try to reduce harm to people, to best serve our forecasters, all of our core partners, and really think about those end users and all of the hazards, individual and multi, that people are facing, and how do we reduce that harm. So thank you all for all of your time and attention and engagement, which has been fantastic. And I'm really grateful again that I had the opportunity to co-convene this with Jelmer. Jelmer, do you have anything you want to say before we hand it to Carla? I know it's late there.
Yeah, thanks so much, Julie. And I just want to join you in thanking everybody for this great session and the very engaged discussions. So many more important things being raised, and we need many more hours and days. And we could dedicate a whole conference to this topic, it seems. I think I just want to finalize by maybe encouraging everybody who is working in this field, not just trying to add another webinar or maybe another conference on this, but because there's so many things already going on, there's so many platforms where these topics are being discussed, but just try to join the things that are already happening and put these social science perspectives on the agenda there. I think there's opportunities just to benefit there and put these things on the agenda that really move the whole field beyond. So yeah, thanks for everyone, and looking forward to how this is going to develop in the years to come. So yeah, I think we are moving on. It's now time for the closing part of the Weather and Society conference, and this will be moderated by Carla Mooney from the Bureau of Meteorology in Australia. I see, Carla, you are having your camera on. The closing session is up to you. The floor is yours. Thanks so much.
Thank you. So yeah, thank you very much. I can't start without sort of just saying thanks to Jelmer and Julie for a marvellous session just now, and what a great way to sort of work towards the conclusion of the conference. I really appreciated the range of speakers and the incredibly engaged audience, but absolutely wonderful organisation from Jelmer and Julie. So many thanks to you both. This is the closing session, and the first thing we're going to do is have a keynote speech from Chris Davies, who's the chair of the Scientific Steering Committee of the World Weather Research Programme and is from the University of Massachusetts. So Chris is going to speak for 15 minutes, and then I'll just do a final wrap up. So over to you, Chris. Thank you.
Thank you. Thank you, Carla. Let me share my screen, or try. It's always a little bit challenging here. Let's see. Hopefully this will work. And I need to go into slideshow. Hopefully you can all see that.
Perfect.
Okay, thank you. Yes, and thanks for the opportunity to say a few things. There's not really much I can add to these 4 days of really excellent presentations and discussion. It's really been wonderful. Just to note that for some of you who know me, I have changed affiliations recently, so I'm now at the University of Massachusetts in Amherst, where there is quite a bit of snow on the ground, and that will actually be something I mention a little bit more as we go on here. But I think it's nice to note some milestones in this interdisciplinary work that's really gone on related to the World Weather Research Program. Certainly, the SARA working group. Now here we are, the third conference, and this is I think really terrific. But I also want to recognize the paper that recently came out in the bulletin of the AMS on the 10 years of the High Impact Weather Project and all of the advances that we've been building on for some time. I think we're still building on them, but really deep dive over a long period into how to make warnings better, how to understand how our warnings are used and where the vulnerabilities are, the sort of fault lines, if you will, in the warning process. I also want to recognize a project that we call PEOPLE, which is an acronym that stands for Progressing Early Warnings for All, oriented to partnerships and local engagement. They've been at it for 2 years now. Some of you may not know a lot about this project, but it really is dealing with a lot of the themes of this conference: the inclusive early warning systems, reducing barriers, creating enablers to access and use warnings, and understanding the context and evolving risk. Just pointing out who is on this steering committee for this project. So looking forward to many great things from this project over the coming years. At least for me this week, a number of things came through. Certainly the emphasis on all in early warnings for all, that this is for everybody. The expansion, I think, really into multi-hazard, multi-audience, multi-impact, this complexity as we go to impact-based warnings is really becoming a forefront of our thinking. And how do we deal with this? Because I think this is a major issue to have effective impact-based warnings, because the impacts are so varied. There's so many constituents and actors all operating at once. And part of that is including the value of different perspectives, cultures, and lived experiences. We just chatted a little bit about marginalized communities and how important it is to have their perspectives. And I think AI accentuates that importance even further, which is one of the things I think of when I wrote this bullet, the promise and danger of new technologies. I did mention snow, and I wanted to say a little bit about taking a long-term view of progress in the warning and response situation. So I don't know if many of you in this on this conference probably don't remember this event, but I certainly do. This was an enormous snowstorm in February of 1978 in New England. And apologies for English units over here on the right. So those are inches of snow, but the 36, 38 is basically a meter of snow that fell in a single storm. And you see on the left that basically the warnings were not sufficient. A lot of people were on the road. They ended up stuck on the road. They couldn't get out. So there were ultimately 3,000 cars that were abandoned, or sometimes people were stuck in the cars for a long period of time. It was a very dangerous situation. And not only that, but they couldn't actually clear the road for many days. And so this ended up to be a cascading problem. Well, fast forward, and I know 48 years is a long time, but last Monday we had a similar event. And snowfall totals on the right, those dark black or dark red places indicate, again, almost a meter of snow in urban areas. Slightly different location. Providence, Rhode Island actually set their all-time record that they had previously set in the storm above. But you look at the road on the lower left, there's nobody on it. And there are a lot of reasons for that. And I can speculate about a few. I haven't done the research on this, but I think there are several factors that have sort of accumulated over time. The forecasts were certainly better than they were in 1978, but they were by no means perfect. There were a lot of uncertainties. I will say the forecasts got better as the event got closer. The forecasts were good within the time window for serious decisions. And recent past forecasts have been very useful in similar situations. People have experience with these kind of events, and the 78 storm was really an iconic moment that's still talked about. And I think when you have that kind of long memory about what can go wrong, it really is motivating. I will also say that cities in the Northeast United States can clear snow effectively. That is, if there aren't cars all over the place. And finally, and this is real speculation, but the pandemic may have actually had a role in this, where there was less of a sacrifice to stay home. People were kind of used to it. They knew how to do work, many of them. Some were not, it's not available for all. But I think all these factors may have had a role. So everything is solved? Well, not so much. So the picture on the right is a very similar incident that happened in Chicago in 2011. Now, this was 15 years ago, but the forecasts were quite good. Everybody knew what was going to happen, and people were still stuck on the road. And maybe the pandemic would have changed the outcomes here. Hard to know. But the thing I want to mention is that even with all of our improvements, there are still some impacts that we are struggling to overcome. The power outage in this recent storm on Monday was very severe, with over 300,000 people without power, in a compounding hazard because of the ensuing cold. This is very similar to what happens in tropical cyclone landfall, where power is knocked out for many people for many days, and often they are dealing with heat in the wake of a tropical cyclone. And so there's a technological aspect of this that I think still needs a lot of work, and understanding how people plan for or maybe don't plan for these kind of eventualities. So there's still plenty to do. I did want to close with a few comments about early warnings for all. As we know, this is a UN initiative that WMO has a big part in, and it's we're still in process. It goes till the end of 2027. We all know that it's going to continue beyond that. Maybe not formally as an initiative, but certainly the work is going to continue. And I think there's some cautionary comments about this, and I think we've touched on them today, and I'm really glad we did, about the AI revolution may not be a revolution for all in the same way. And we need to be careful about it be creating non-inclusion. We just talked about that. We haven't really talked about warnings and climate change, but how warnings have to adapt to those conditions, and the vulnerabilities are. And I tried to indicate this with the graph below from the Climate Risk Index in 2026. These are the countries that had the biggest impacts of climate change. And it's measured in various ways. But if you look at it, it's also many of these are the countries that lack effective early warning systems. And so in some ways, we could be doubling down on the problem as we go forward here if we're not careful. So this unevenness across the globe, I think, is a real concern. So what can we do? Well, on the left is sort of the four boxes, the four pillars of the early warnings for all. And I wanted to, it does frame the value cycle in some ways. You can kind of see that over here, but it's not quite the value cycle because there's a lot of interaction between these boxes as well. But you can sort of think about it that way. But this is also from that same article about where the progress has been in the different pillars. And I want to point you to the disaster risk knowledge, because that's the place where things were really low and they're better. But unless you really have the complete cycle, there are going to be gaps, and there are going to be some really important places where the system still doesn't work. And I think the point here is research is necessary in all four pillars. We tend to think of research maybe more in that upper right pillar about detection, observations, and monitoring, but I think this meeting this week has pointed to research in all four places as being really important. And my last slide is really, I just want to emphasize that WWRP is developing a new implementation plan for the period 2028 to 2031. And we are incorporating a number of ideas that are very relevant to this meeting. And these are not finalized wordings, but certainly they've been vetted somewhat, but I think they will change also. But when we talk about observations in Goal 1, it's both of the physical and societal systems, and really understanding how people make decisions and understanding vulnerability, understanding all aspects of the societal problem. When we talk about prediction, we're really using prediction to understand decisions, especially under uncertainty. And finally, when we are advancing methodologies for warnings, we are doing it for everyone and really for all. I think that's the important thing. And so I like the fact that these kind of echo some of the themes that we've heard about this week. And I just want to close with a big thanks to so many for a great conference and a chance to make a few remarks here. But thank you so much. This has been a really great event.
Thank you very much, Chris. Those wonderful closing remarks. I really appreciate it. Yeah. We don't have time for questions, but I hope people will put some comments in the chat and feedback to you. But thank you again. It was wonderful. Okay. I'm just going to make a few comments now. So my name's Carla Mooney and I'm speaking, it's a great privilege actually to be able to speak on behalf of the SARA working group to provide a little bit of feedback at the end. So before I go any further, I just want to acknowledge the World Weather Research Program with many thanks for their support throughout the conference and sponsorship of the conference. And Lobelia as well, who provided funds for our website, which was a great step forward, I believe, in the way we run the conference. And as Chris mentioned, it's the third of these conferences that we've run. Many of you have been here for the whole week, so I can only just say what a week it's been. We've had an online conference in 2 different time zones over 4 days, and we've really continued with this free access of the conference to ensure reach of our work and to make it as accessible as it possibly can be for as many people as it can be across the globe. The theme of the conference was Whole of Society Approaches for Weather-Ready Communities, and we've had 5 sessions. A couple of them have been sort of in the traditional space of SARA, communication methods in social research. We're looking a bit more broadly at this idea of transdisciplinary science, importantly, the emphasis on social inclusion, and then looking at innovative areas, which is integrating AI applications. And I think it's been a wonderful way to end with that particular session. Next slide, please, Isha. I really want to acknowledge all the people who've been involved. So on the left-hand side of the screen, you can see the conveners, and many of them are SARA members, and I'll talk a little bit about that later. There's a few who aren't, and I really want to acknowledge Philip Bukowski, who's made a great contribution, the team from the University of Georgia who stepped in and supported the interdisciplinary session, and also Julie Demuth, who came along today. Valentina from Argentina represented YES, and so we've brought in a whole lot of different people into supporting the convening of the conference. We've had some fantastic keynote speakers. Erasima provided a broad introduction to the conference. Victoria gave a great talk about interdisciplinary research with Indigenous people and climate change. And of course, we've heard Chris today providing this insight around AI. And of the other Chris Davies, a great summary of the work that's been going on through the conference. And so reassuring to hear something about saying we are making progress. I can't name all the presenters, but we've had a number of presenters in each session. The presenters' abstracts are available and contact details on the website, so I encourage you to have a look at that and reach out to people if you would like to. Can you go to the next slide, Michelle? So I just wanted to highlight that we have speakers from 54 countries. No, we had 54 speakers from 26 countries. Absolutely wonderful. The inclusion session last night, or whenever it was, this was for you, was very, very happy that they had 11 speakers from 11 different countries representing a whole range of different interests. So it's really fantastic. And we're really grateful to be able to provide an opportunity from all different places to present to an international audience. Next slide, Michelle. it's, you know, I had a goal, which was to get more registrations than previous sessions. So actually each time we've run the conference, we've increased the number and reach of the conference to participate, for people to register and be involved. So we had 850 registrations from 117 countries. More remarkable and I think is the amount of engagement we've had from those people who've come along. It's been so nice to see the chat going live, people being willing to ask questions. There's been whole conversations going in the chat and people sharing information, contact details, references and all that sort of stuff. So we're really happy about that idea that we're building a community and supporting each other in this endeavour. Next slide, Isha. We also are very interested in building links between research and academia and meteorological agencies and other organisations. So we've had around 40% of registrants are from research and academia and around a quarter from Met agencies like myself. And that's really creates a very rich exchange of information. We've had people from NGOs, other organisations and government. So that's, you know, it's really good to see that breadth of people participating. Next slide, Isha. We've also made a 50-50 sort of representation for male and female registration and participation. So that's also really great and stepping towards meeting the broader goals of inclusivity. Next slide, Isha. So I just want to talk a little bit about Sarah and next steps. So Sarah is the expert working group aiming to advance the science of social and economic applications of weather-related information and services. And these are my plain English versions of our goals, which is building the social science weather community, creating opportunities to share information, methods and expertise, integrating knowledge, creating links between research and operational agencies, and identifying gaps and needs and challenges. And I really feel very confident that the conference, the way it's come together and all the generosity of the speakers, presenters, conveners and organisations involved have really helped us progress the achievement of these goals. Next slide, Isha. So you can be involved. We've got an open call for new members into the Sarah working group. We're looking for someone with AI expertise, but there are also broader skills that we are looking for. So if you would like to be involved in the Sarah working group and have an opportunity to be involved in events like this, we really encourage you to apply. Next slide, Isha. An initiative of the Sarah Working Group is really actually trying to understand social science capability in met and hydro agencies and research organisations that are supporting them. And we'd really like people to respond to this survey. So if you want to see the QR code, please take that. And that's going to help us shape up an understanding of what work is going on, what skills people need, and where the initiatives are. That will also be included in the final wrap-up email. Next slide. An important thing that we're doing is to look at how to communicate the outcomes of the conference. And I want to draw your attention to this special collection, which is taking submissions through the conference, about weather and climate-induced multi-hazard futures, forecast, communication, preparedness for society. So that's NJP, natural hazards. So this is a new collection. We really encourage people to contribute to that if you're available to do so. Next slide. Of course, there's a survey for feedback. We want more feedback. We really want to make the conference better, more accessible, more usable, more valuable, more dynamic. So if you've got anything to say, we really appreciate your feedback with that. Next slide, Isha. And of course, last but very much not least, special thanks to the organising committee. And you've seen many of these people during the week. Jelmer just now was involved in the in the session about AI. Isadora led the first session, Don interdisciplinarity, and Everest from the gender and equity session yesterday. Each of these people have made enormous contributions and voluntary contributions outside their work time, and I really want to acknowledge that. Particularly, though, I want to highlight the work of Isha and Jeuring from the WWRP Secretariat, who've done amazing work and supported us all the way and made great contributions, and really want to acknowledge their assistance and help. So many thanks to all involved. And I think that's about all I wanted to say. So apart from just saying many, many thanks to the presenters, organisers, WWRP, Secretariat, and look forward to seeing you in 2 years' time, if not before. Okay, thanks.